please send me a message in chat, for example. Do you see everything? Is this text good for you, or maybe need to make it smaller or bigger, or maybe in the dark background, or light background, or probably what do you want to change in the this presentation of this code, presentation of the materials. If everything good, and I work with the PyCharm. I'm using light scheme in this PyCharm IDE, and if it's good for you, I think I will use it tomorrow. Tomorrow too. And what else? I will use some tutorial in English. It is good for you to see it in your screen, on your screen. For example, here you may find the explanation of the button, canvas, check button entry, or operator and description. Okay, if everything good, maybe do it some bigger. Okay, just I try to do it. Okay, probably like this, because I use the notepad that I think I can do it. Okay, is it good size? Yeah, if I use PyCharm, I can increase size too. When we start to use PyCharm, I think I can do it. I can change the size of the font. Okay, okay, good. Thank you, Olga. Just now we try to start, because now already 10 a.m. and of course you can interrupt me when you want to ask questions. You may use chat, you may use your voice yourself, and I think if everything good, I will continue. Okay, let's begin. Now we have 16 participants, but I'm waiting more because yesterday we have some problem with Zoom translation, but now I think everything is okay, and more participants come to this workshop. What does it mean, Tkinter? Tkinter is the library which is a standard graphical user interface library for Python. Tkinter provides a powerful object-oriented interface to the TK GUI toolkit. Probably somebody already works with Tkinter, or already worked with Tkinter before, but now I try to explain how to combine it with some tools of image processing, for example, for observation, medical images, or medical photos, like X-ray images, for example, or CT images. Creating GUI or GUI application using Tkinter is an easy task. All what you need to do is perform following steps: import the Tkinter model, Tkinter library, create GUI application main window, add one or more of above mentioned widgets, enter the main event loop to take action against each event triggered by user. Let's try to do something simple. For example, creating one window using Tkinter. First of all, need to import Tkinter, and we try to import Tkinter, and we will do it like import Tkinter as TK. Import Tkinter as TK. After that, oh, I think need to move it to the left side. After that, we're creating window using this string. After we creating a window, need to make a main loop cycle using this, for example, window main loop string. But we want to put some message into the window, into the Tkinter window, and I think we can do it using this function we think TK label, using this string. And I use greeting pack. Pack is the function for put some objects into the window, onto the window, but I think I will explain it later how we can use it. Okay, now we're creating a window with a simple text. Let's try to see how it works. Let's look how it works. No. Yeah, need to use examples. You may see we're creating a small window here with this text: "Hello Tkinter," "Привет Tkinter." Maybe we can change it. "Hello Tkinter." For example, run again. Sorry. Yes. Here you may see a simple window like with text "Hello Tkinter." Let's continue. What we can do else? Now we can add the new widget to our application. Label widget. For this, we need to add this object label. We already did it with greeting TK label, but now we try to make some changes with this object, with object label. For this reason, need to delete this greeting object and doing some operation with label. Let's try to see the result, what we can do using the different operation inside the label. Need to use function for put this object on the window. Yeah, you may see here we using black background and white foreground. You may change the colors of background and foreground using simple names of the colors. For example, we can change it for red. Run once again. Yeah, you may see here window with label and the color of the label is black. Label background is black, and the color of foreground is red. Let's continue. Let's make some changes with the size of label. Let's copy this example to the pie chart. Here you may see after the foreground and background colors, we put more operations with width and height. And now we use 20 and 20 sizes of our label. Let's try to run and see results. Okay, you may see here an object label and the size 20 by 20. But we use label pack. We use function pack. It is the reason why we have this. Why we can change size of the window, and we see the result of size of this label. And we have a different means of size, it doesn't mean that 20 by 20 is a square. No, because in this Tekinter, 20 height doesn't mean 20 width. Need to find that we can make a square, for example, using this. We have a special relation for vertical size and horizontal size. Okay, let's continue. Now we try to create a button. Button is another object in Tekinter, and I want to show you some explanation. The button widget is used to display buttons on your application. Before we using label widget used to provide a single line caption for other widgets. It can also contain images. Label is very important for us because we're using images in our final application. Now we try to create a button. Let's copy this text. Well, what we can see here, window means this string means we're creating a new window. This string means we're creating button object using function tk point button with text push on me. Size of this button 25 by 5. Background is blue. Foreground is yellow, and we're using a pack method for put this button on the window. Let's run this example. Yeah, you may see here we're creating the button. We have this button, blue button, and we can push on this button. You may see the result. But now this button doesn't create something. Okay. Later we will create some event when we push on this button, when we click on this button. Another object in Tekinter, another widget in Tekinter is entry. Entry widget is used to display a single line text field for accepting values from a user. Let's try to create entry. Run it. Yeah, need to add some more string. Here you may see the entry widget. Of course, you need to add the window main loop to your code in Tekinter, because when we use Tekinter here, it's like a cycle. we are showing this window each time. Okay. Now we can write here some later, for example, hello. Also, we can do some actions with this text, and later I will show you how we can do it. This entry widget is useful for creating forms where you can put information, for example, some data or digits or something else, what you want to use in your application. You may use the parameters of entry widgets. For this, need to add in the brackets next text. Like this. Let's try to check what's happening. Yeah, here you may see we are creating the form with blue background and yellow foreground, yellow letters inside. Okay, how we can work with the entry widget? We can use function entry get. It means that we can get information from entry form. For example, we want to get information about name. Paste name, entry get, and print name. No, okay. We will do it later. Name entry get. Yes, let's start. Let's try to check what's happening. Blue background not so good for your for the view on the screen. I think need to change it to the yellow, for example, or other colors. You can change the colors using code of the colors, like this. If you use this method of codification colors, you can create objects with different colors what you want to see. Or you may use, you may continue to use names of colors. Let's change place. And black, for example. Yeah, here you may see yellow field and black text. Ivan, Ivanov. Here you may see the this here you may see that we can write here the text, write information, and now we can use the get method when we want to get name from this form, from this field. Now we can change, we can make some changes with this information using other methods like entry delete. What does it mean? 0 or 0 and 4? We can check it. Firstly, need to put some information before. We can use this code, and we can run this code by string, but I think you can do it in your homework to use it string by string and to see the result, what's happening if we use entry delete 0, entry delete 0, 4. Now we try to continue with another function, another widgets. We can use a text box with long text inside. Let's try to use this function. This let's copy this code, put it inside, and need to put window main loop. We are creating the form when we can put long text, for example, and you may do same operation like before with long text. For example, you can get information from this text using text box, using get method. For this reason, need to for this you need to add the string text box get to get information and run it string by string. And I think you can add what's happening with your text in your homework on the Moodle system. This is the second part of your homework. Also, we can add the new object. Now we are already knows we already know information about button, entry, label, text box, and our next operator, our next function is frame. Frame widget is used as a container widget to organize other widgets. It is very useful, and if you want to create your application, of course, one of the method using this widget to organize others. Let's try to check what's happening if we try if we using this widget. Need to copy this. Let's run it. Now we're creating frame, but nothing inside. Let's put something inside. Okay, here you may see frame A and frame B, and we are put we are well, we have two labels inside the each frames inside each frame. For example, we are creating a label with the text. We are creating label with text. I'm in frame A, and we put this label in the frame, in the first frame, frame A. And the text I'm in frame B, we put in the frame B here. You may see this code. Here we use pack method for put information into the window. Okay, I think it's very simple. It is very simple, and we can continue. Let's try to change places of these frames. To change place of this frame. Paste. Let's try to run it. Yeah, you may see we can change place of the frames. using this part of the code. What else? Also, we can add special effects like border effects to our application when we use frame. Let's copy this part of the code. Here you may see we are creating objects with different border effects. For this, need to use special names of the border effects and the special objects of TK library: TK flat, TK sunken, raised, groove, ridge. Here you may see the difference of these border effects or relief. As you can see, we're using frame and pack method for put these objects on into the Tkinter window. Let's continue. Let's try to change some parameters of the frame. For example, width and height. Let's try to run it. Here you may see the result. This is the red square, 100 by 100 with background red. It is the frame, first frame. Second frame, 50 by 50 yellow, and third frame, 25 by 25 background blue. We use the pack method for placing these objects. Okay, and what else? Now you see before you saw before when we use pack method and width and height, for example, 100 by 100, we can get the result like a square. But if we add parameters to the pack method of placing, we can get other result. Here, you may see what's happening. We use fill parameters. It means we are filling this area from the left border to the right border. And when we try to resize the window, it is changing with the window. But here we use fill TKX. It means we use fill and you may see it changes if we resize window by x-axis. Horizontal. Okay, let's continue. Let's try to add more parameters. If we add new parameters tk y, it means that we can resize frame object to the y-axis, vertical axis, and side tk left means that we can put frame object to the left border of the window. Default, it placing to the up border of the window. We can change it for the right, for example, and it is placing directly to the right border of the window. Let's change more. Here you may see we can use fill tk boss. It means when we try to resize window frames, resizing with this border, because we are right parameters boss. Expand true means it can expand. Also, we can use coordinates for placing objects in the kinter, like this. Here you may see this frame, this label place on the 0 and 0 coordinates, and this yellow label placing is placing on the 75 by 75 x and y. We use other method to placing objects. Place. These methods provides us to place objects where we want using coordinates. Okay, next. Okay, we understand what does it mean geometry managers like pack and geometry managers like place. Now let's try to make something interesting using these geometry managers, using these methods. Here you may see we can use pack method, for example, to create this object. Now we use frame because I want to show you how this pack method working. We are creating the table 3 by 3 using cycle for E in range 3, for G and in range 3. We are creating this table, and here we put each object, each frame on each frame on its place. you may see, and we put the text inside this label into the frame, inside the label widget into the frame. And we use grid method to put this object, to put frame object. Grid method provides to put objects using number of row in number of column. Okay, next. Here you may see the different results using grid. And we can now you can see that we use the raised relief function, raised parameters, raised parameter, and we use the grid method to placing this object into the window, onto the window. Okay, next. Same result. Yes, we use special parameters pedx, pedx, and pedy. What does it mean? It means that we can place object with the space between there. We can change these parameters. For example, 10 here and 10 here. Let's see the result. Yeah, you may see we can increase space between frames. It is useful for creating your application with buttons and frames. Okay, let's continue. Same result. I don't know why I put it here. Okay. Other example. What we are using here. Here we try to change window. For this window, we are using label widgets and grid method for placing these widgets with a special argument sticky. With special argument sticky. If we use sticky, we can change placing of each labels inside the window. If we use n parameters, we can place it to the north side. If we can use, if we use E, for example, It means we are placing objects to the east side. And if we use S, south, W, west. Let's try to change it, for example. W, north, okay, S, south. Let's see the result. You may see here, close to the bottom border. If we use W, to the left border, and E to the right border, close to the right border. It means we can use a sticky parameter when we want to place our objects to the special area, on the special area of the window. Sorry for this technical problem. Are you hear me? Please, somebody answer, because I cannot understand what's happening. Okay. Thank you. I will try to continue. And tomorrow we will continue with the Kinter. But now I want to show you the final results. What we can do with the Kinter and OpenCV, for example. One more small examples, and one more small example, and after that I will show you the test application which you can create using the Kinter. Okay, I will try to share screen. Good. And we are we stopped on this small example using the sticky parameters to placing the objects, and you may see here we can change the size of the column and rows. And we can place it using these parameters. We can combine direction, east and west, north and south, north, south, east, west, for creating these objects. Okay, but now I want to show you the final result, or not so final, but simple application with the tkinter, which can help us to analyze medical image. I try to run it. Here, yeah. Oh, just sorry. Yes, this one. Here you may see the application with window detector 1.0. We can choose a file, open, and for example, image unnamed. It's a CT image, computer tomography image of the lung. And I can apply tools of OpenCV, which placing inside the tkinter window. We can use basic tools like making negative. This is the negative negative image of original image. You may see white colors staying black. After that, we can make grayscale. But here is the black and white image, and you cannot see the difference. We can make binary image using special parameters. For example, like this. You can create these sliders in your application. Here you may see it is already good. Why? We can remove, for example, some not interesting objects from our image using this binarization. And you may see we can get here object which isn't which we cannot understand what does it what is it. We can use this binarization. Yes, and we can see more details using this binarization, like here. Do you agree? If we look at the left image, we cannot see these details like on the right image. Yeah, but we can get another results if we try to move this slider here. Just okay. Yeah, we can get other result like here, but we can use other type of binarization, and we can tune the parameters for getting this result, for example. Not black on white, but white on black. We can change the parameters. Okay, what else? Cancel. Basic function. Another type of binarization, threshold bin. You may see we can get the result with only borders, only contours. You may see it's interesting. If we look at the right image, we can get more information about these photos. What else? We can use special function CLAHE, CLAHE. This is adaptive contrast function. We can get the more contrast image you may see with the specific details. It is very interesting and I think very useful for medical personnels. You may see, very nice. What else? But now I think there are a lot of same applications which helps medicines, which helps doctors to analyze photos like this application. But you can add more specific tools in your application. You can use artificial intelligence, for example, to understanding, to recognizing objects inside the photos. It's like a simple example, and you can add your specific tool. But I want to show you more tool. For example, special tool for recognizing circle objects inside these photos. I use the contour. One more interesting, CANI. CANI instrument give us the possibility to see the contours of the objects. And we can use these object contours. What's happening? Oh, need to turn to origin image. And after that, we start to use contour object. Okay, you may see, but this is the some letter L. It is not interesting for us, but you can tune parameters and find something interesting. Oh, you may see this instrument give us the possibility to recognize a circle object inside the photos. It may be interesting for medicine personnel to analyze, for doctors to analyze CT images. And here we can continue to change parameters. Nothing happens to these photos, but I think I can use other. Let's try to use other photo like this. Let's try to do something from this photo. Okay. Yeah, something happening, but the contours are black. Yeah, you may see black. Need to change some code because I use a PNG image. Need to add this functionality. But you may see if we change the parameters, we can get the contours of these circle objects. We can get this. Very nice. It works. Okay, other image like this. Basic origin. Let's try to use contour function. Okay, we see the letter R. Yeah, need to remove this object from the photos. Yeah, nothing interesting in this, but I see this this detail. It cannot recognize this, but it works very good on the other sequence, on the KT image. It works good. Okay, and this is the final application. What we can create after our workshop with the Kindle. Please do homework, and I will upload this code and examples and links for understanding more information, for understanding more about the Kinter, for know more about the Kinter. And I will add all examples, all codes to the Moodle system. If you have any questions, please ask me in the chat or directly. Можно на русском спросить? Please, if you have questions, any questions? Do you understand everything? Probably you have the questions about final application. Ага. You mean Clache function, yes? Контрастность Clache function. Okay. How it works? It is the special function in OpenCV. I can show you this. We are creating the special function with this Clache method. Just I try to find it quickly. Yeah, here. This method using no, this is only use CVD color. Yeah, this is only on Clache. This how we can press the button, and yeah, and when we press on Clache, we can go to the command self edge limit. Yeah, here, edge limit. This is our function. And here you may see method create clache. This method provides us to use the special adaptive histogram. You can find out more information about clache method, contrast limited adaptive histogram like this. And if we apply this clache with different parameters, like title grid size, here I use the grid size 8 by 8. What does it mean? It means we separate window with image on small windows, and we use the adaptive histogram. We can equalize the histogram using the special function. And when we equalize histogram, we can get more contrast image with the specific features, and we can understand, we can get more information from this image. It is very useful when we work with very noisy images. When we work with noisy images. For example, also we use this clache function when we try to understand what object inside the water, inside the sea. We use same function for our underwater robots. Is it clear? Thank you. Thank you very much. Anything else? Okay. Thank you very much for your question. Thank you. I think you can work more into the Moodle system. And now we have a small break. Let's try to. Yeah, we have small break, and after that, you may see on the program. After that, we will come back and continue with lectures of our colleagues. Thank you very much for your attention. Please using Moodle for getting information about this lecture. Thank you. Our next presentation from Andrei Koval, Voronezh State University, mobile networks infrastructure, packet tracer simulation. Andrei, are you ready to show us presentation?
Yes, I'm ready.
Oh, thank you very much, Andrei. Okay, in 11:30, your time in 11:30 Astrakhan time, 10:30 Moscow time.
Yes, just in 20 minutes, I will be ready.
Thank you very much. Thank you.
Thank you.
Dear participants, let's try to begin. Andrei, are you ready? Andrei, are you ready? I think you can start your presentation. I think you can start your presentation. Так, что-то со звуком было. Со звуком было. Андрей, попробуйте запустить презентацию. Андрей, попробуйте запустить презентацию. Андрей, попробуйте запустить презентацию. Андрей, я вас не слышу, к сожалению. Я вас не слышу, к сожалению.
Can you hear me now?
Yeah, we are hearing you. Okay, thank you. Let's try to run your presentation.
Okay, but I cannot share the screen. I can now. Do
Now,
it.
okay.
Mhm. Okay. Can I see my presentation now?
Yeah, we see everything. Okay.
Okay. Okay. Some echoes. I don't know why, but I think we will start. Okay, let me introduce myself. My name is Andrei Koval. I'm from Voronezh State University. The topic is mobile network infrastructure, packet trace simulation. First of all, let me tell you about the purpose of network structure studying, learning about it. This is for developer to more clearly understand potential problems with delays and some other problems caused by infrastructure. But there are some specifics about mobile networking, mainly about control of the network, because it's a little bit different from what we used to use in our corporate intranet networks. It is controlled by network operators, and hence we need to know what we can demand from them, how we can how we can establish relations with them, and how to, of course, troubleshoot and check path characteristics. And what are these path characteristics? First of all, what is network infrastructure? Network infrastructure, mobile network infrastructure, is infrastructure which provides mobile application with IP connectivity. Now it is IP version 4, version 6 connectivity, and name resolution. Name resolution is required to locate services, of course, in terms of IP addresses, because location in the internet, in IP networks, is defined by the addressing. So these two infrastructure services actually are the same as in typical internet application services. Since 4G LTE network has all IP enhanced packet core, so-called also known as APC, EPC. So this turns mobile infrastructure to almost ordinary IP network. So all services are provided like an IP network because they are just using IP technology. The same is about fifth generation and sixth generation upcoming. So that's to optimize and troubleshoot applications, mobile application, if it is required, if application, and we will speak about this later on, requires, so has specific requirements for network parameters, especially interactive ones, for example. Developer need to know basics of IP, version 4, version 6, DNS, and of course service models such as quality of service and guarantees of quality of service. In order to study this subject, of course, it's better to use simulation tools because infrastructure, mobile network infrastructure, you may say, is not easily accessible for learners, for students. They are controlled in a different way than intranet, and that's why it is not so accessible. So we can use simulation tools, and we in Voronezh State University are using Packet Tracer, which provides some functionality to simulate mobile networks infrastructure. Of course, not all is possible, and I will show you what is possible, what is not possible using a Packet Tracer, and some specifics will tell you about functionality of Packet Tracer. For those who want to have hand-on experience, just now for today, I ask you to download Packet Tracer tool. Let me see how to do it for you easily. For example, we can use this URL. Let me see whether it's possible to let me see, meeting controls. Let me see. So these are okay. So you can download it using this URL. So how to chat it? Who knows? Cannot. Here I can say chat. Here is it.
Do you have any problems?
Just one moment. Where is it? Maybe I need to stop sharing and then chat. Okay. So here is it, the URL for those who want to download it and
you can send.
have a hands-on experience with it. Okay. Let's return to presentation. Let me tell you that there is some problem with other version than 7.11 as concerning to mobile and cell in particular networking simulation, because later version are crashing while setting IP version 6 parameters in it. Everything other things are working quite okay, but while working with IP version 6, you have a crash program. Previous versions do not support IP version 6, and then you, of course, can use it for IP version 4, but it's not the full functionality. So somewhere from version 7.2, IP version 6 problem in central office. So this control of base station. Something was wrong with it, and now we're waiting for maybe updates in this. But I haven't tested version 8. Maybe version 8 is repaired. Packet tracer tool, it's better to call it Cisco packet tracer because it is provided by Cisco company, Cisco Systems company. And this is a free tool. You can download it from Cisco site. The reason why I gave you a URL is that first of all, it's a particular version we require. And the second reason is that in order to run this tool, I think if you install version 8 or current version, I think you have to use your Cisco account. So you need to spend some time to create account, to find it tool. So that's why I just give you this URL for downloading. While I'm speaking, I'm for those who want hands-on experience, you can, while I'm speaking, install it. Maybe you need to check it, of course. Let me show you. You can download it, and then let me see. For those who want to check it, the program exe file is signed by Cisco, so you can in the properties of this file choose digital signature, details, and then look for a certificate. In certificate path, you can see all certification authority signatures. For example, here you can see that certification authority DigiCert certificate and corresponding thumbprint if you want to be very accurate with unknown for you executable file. Okay. Then you just double click and install it. And as now for those who want to run it on Linux, it is also possible, but I don't have installation file, so you need to download it by yourself. Okay, what we will see in the end while we are creating model, so we will see such topology. This topology already has been configured by me, and you also can download it from the URL I gave you. So there are several topologies: Wi-Fi topology, to check cellular network in version 6 only, and the final version of this project is version 6, version 4, IP version 6, version 4, already configured project. So finally, you will see this topology where you can see base stations, central office control base station, and some infrastructure which provides mobile clients with name resolution and some imitation of services, web server, inside intranet corporate network. Okay. Let me tell you about outcomes, our goals, which typically set up for such courses about infrastructure. Ideally, mobile service developer should have understanding about QoS concept and implementation of this concept, which means that he or she must understand how the network provides services, what type of services network can provide, how to influence this type of services, and how to influence. You need to formulate requirements for mobile network operator. Also, in some cases, rarely, you need to configure a basic quality of service infrastructure. What are these circumstances under which you need to configure it? For example, mobile application for intranet network, for corporate IP network, means that you can control this infrastructure by yourself. So there is no operator, mobile network operator. So you are by your own in creating appropriate QoS infrastructure. So for that reason, you need to know, not only know the concept, but also should be able to configure it. Particularly, you need to configure routers, you need to configure IP equipment in order to provide the application with guaranteed or best effort or some other type of service inside this network. Just a few slides about LTE architecture. What is it? So as you can see, mobile device, it is known user equipment in terms of LTE, must have LTE interface, radio interface, 4G or 5G now interface. It is identified by the 64-bit international mobile subscriber identity. I'm sure you know about this IMSI in SIM card. Then you can see base station. It's called in LTE eNode B evolved base station. Router infrastructure, such as servicing gateway between eNode B base station and PDN gateway. PDN gateway, which is a route to other networks, internet, for example, or network of other mobile operators. As you can see, the network can be subdivided into radio access network, UTRAN, and all IP enhanced packet core, about which I told you just before. A little bigger picture is the global cellular network, which is simply the supernet or network of other IP networks. Here you can see home mobile carrier network, which is terminated by the P gateway. P means packet data network gateway, PDN gateway. And another visited mobile carrier network, which is also terminated by the P gateway, connected through exchange, inter-carrier exchanges, or public internet. So as you can see, the global cellular network is just a network of IP networks now. No more old legacy dedicated network. Truly speaking, they exist now, but the tendency is to connect it all through IP network, through the internet. The mobile client roaming from home network to visited network, and you can see that it is served by the mobile base stations of home network or visited mobile carrier network. So it means that the infrastructure is IP, as I just told before. Okay, let's look at the packet tracer. What do we have here? All about wireless devices is within wireless devices here. You can just drag and drop icons of this object, and we will start from end devices, of course, smartphone. Then we can add wireless device from wireless device category, cell tower, central office server, and some routers to emulate internal infrastructure. Let it be, for example, 2911 working host, you may say. Let's look at configuration of smartphone. What do we need to tune it here? As you can see, by the way, it is already connected. It's already connected with cell tower. And why it is connected is because for 3G, 4G, cell provider name is set to PTC cellular. So we can check, we can type here anything we like. And the network name, of course, must correspond to cell tower network name, which is configured here. For example, like this. The next thing is control of base station, which is called here central office server. It must be connected to cell tower through dedicated link, which is called here cell coax cable, and we can use automatic type of link, but finally it is using coaxial cable. Okay, the capacity of central office is 8 connections, coaxial connection. Another one interface is backbone, which is used to connect to wide infrastructure. As you can see, it has IP configuration, IP version 4 and IP version 6 configuration. So you need to connect it to the router, and I can use here any router. Let's connect backbone interface of central office to router. Let's return to central office. Central office is required to control base station, to control clients of the base station, and for that reason you need to serve infrastructure, IP infrastructure of the client, which is IP version 4 or IP version 6 infrastructure. You can see here DHCP service, DHCP version 4 and DHCP version 6. By default, it is 172.16 class B network. And in order to support DHCP, IP version 6, you can configure DHCP version 6, which requires pool, create pool, create some local pool, like this, a local pool. Oh, sorry. Just one moment. Test local, I call it. And set some addresses. For example, like this. You can use a part of 64-bit address space, of course, but I will use the whole one. Let me see. Okay. Also, you need sometimes to configure some type of authentication to authenticate cell tower towards central office. As far as concern end devices, you can use DHCP configuration and after config for IP version 6. Let me see. What's now do we have here? Finally, you need to set up interfaces for backbone and for cell tower. For cell tower, already it is configured to 172.16.1. For IP, we can use something like this. It's enough. Also, we need to configure infrastructure, which is represented by the router. We need first to switch on interfaces. I am switching them because I don't care about the number of interfaces here. As you can see, the link is up. And we need to terminate backbone with IP address. Let it be, for example, 2, network 2, and default gateway to 1. IP address also for the backbone must be set. For example, it could be the next one, because later, because previously we use 0 network. Let it be network 1. And default gateway, oh, sorry. Like this. And default gateway, let it be finished by the 1. And finally, we need to set up the infrastructure end, corporate network end, all this, or provider, internet provider, and all this infrastructure. So let me see what was the interface for backbone communications. I think this is gigabit Ethernet 00. Yes, it is. And let it be IP version 4 address 172.16. Second, I think network 1. So that's okay. Let me see. As you can see, 3G, 4G interface obtained address from the central office through base station. And also it is obtained, IP version 6 address starting from 2001 and 0. Squeezed by the actually it is 0 network, as you can see. You can use ipconfig in order to observe IP configuration. There is a very funny command, IP version 6 config, which doesn't exist in reality, but it is implemented here in packet tracer. I don't know the reason, but it is so. As you can see, we have a global address, global IP version 6 address here. And also we can ping, for example, ping, what do I ping? Let me see. I think central office, right? Yes. Oh, no, it's not central office. It's already router. It's already wired network part. So we actually ping it. So this is central office. Let me see once again. 1, 2. Okay. Like this. Yes, you can see I'm pinging now central office device. And also I can ping. I think, no, by now I cannot, because we need to add some, of course, some routes. Router 0 doesn't know anything about network 0 networks. That's why we have timeout. Sorry. Also, I forget about IP version 4 infrastructure. This is a central office. And this is our router, which doesn't have routes by now towards cellular network. And so this is our central office again. Okay. The next, the backbone interface. As far as concern continuation of the network, I think it's trivial. It's just like any other wired network, and there is no any difference in typical wired configuration. What else you can simulate here as far as concerned cellular and wired network? You can use physical view of the network and just move cell tower and create some closet, place equipment in the closet, and by this you can simulate several coverage area by the cell towers and simulate roaming between them. The same is about Wi-Fi access point. You also can distribute them all over this map and simulate hangover of mobile clients with access point and cell tower. Just to limit time required, I can open already configured network. Let me see. So this is a final configuration with version 4 and version 6 functionality. You can see here internet service provider router, which actually intercommunicates, bind corporate network, corporate web server, and mobile client server. There is a lot of application on smartphone, so-called smartphone. By the way, it's very funny that we can run some commands in Windows command line because it's a smartphone. But that's a kind of humor Cisco provide us with this packet tracer, I think. Nevertheless, also we have a web browser, and we can check our website and also check name resolution provided by the DNS server. So the infrastructure, wired infrastructure, contains internet service provider, router, corporate router. In this case, it's Voronezh State University router, DNS server of the provider. I can show you its configuration here with two records about web server now on IP version 6 address and about web server on IP version 4 address. So there is no quote A records, it's simply simplifications here in packet tracer. It is just A record is called A record, both for IP version 4 and IP version 6. Okay, let's check it out once again. Sorry, I used smartphone 1. As you can see, we can successfully connect to Voronezh State University website, and by the way, it is done in IP version.
Andrei, excuse me for interruption, but you are show us the presentation or another resource, because we see on the presentation.
Sorry. Sorry. Can I share the whole?
Yeah, you may share all screen.
Is it visible now?
Now we see only PD. What? Now we see black screen.
Can you see packet tracer now?
We see only black screen
Ah,
with.
sorry. Okay. Let me then connect to.
Mhm.
Like this.
Oh, yeah.
Mhm.
Now we see.
Okay, I'm very sorry. I'm very sorry for you not to see the previous time. Due to echo, I had to diminish the volume, and I couldn't hear you. Okay, let's continue. So this is the final configuration of the network. Let me briefly speak about the devices I used here because you haven't seen them. The devices concentrated in wireless category, wireless devices. I use cell tower. I use central office. And smartphone from the category of end devices. Here is it. We connect central office using coax cable, or you can use auto configured like this. Configuration of cell tower requires let me see. Let me see what can I do here. Okay. And also I use routers of any kind, which I connect to central office to emulate wide infrastructure. Wide infrastructure. Like this. Okay. Due to limitation of display and sharing different windows of packet tracer, sorry, I will show you only the main window of packet tracer. And you can do it by yourself when you load the cell packet file from download link I posted in chat. You can check it by yourself, pinging 3W VSURU or 3W version 4 VSURU DNS names from the smartphone sites. Okay, let's continue with quality, which of course is much more than sending packets in this infrastructure. We can check it using ping, of course, but what about quality of transport? What about quality of service provided by the mobile infrastructure? Let me redirect you to presentation. Okay, there are several type of applications, and let me just show you the typical list of them: email, file transfer, web, which is the basic from where we started, you must say. remote desktop, remote login, chat, multi-user network games, more modern, with more requirements, remote control, for example, telemedicine, where you control devices, control instruments, streaming, video streaming, for example, YouTube, Netflix, voice over IP, video conferencing. The list is from old services towards modern services. Some are known as real-time. What does it mean? What does it mean real-time? The real-time guaranteed response times within a specified time. Specified time could be very different. For example, if we are speaking about the weather forecast, it could be hours. And if we're speaking about the speech conversation, anything more than half second delay, especially if it is varying from time to time, would create a problem of conversation. People cannot adapt in changing to changing delay, and the service would be in that case, for example, in this case, is not possible. Application requirements. There is a lot of application requirements we can have, but let's name path characteristics. They are bandwidth, delay, delay jitter, which is variation of delay, packet loss, main of them. So in this slide, you can see various applications requirements for file transfer, for real-time audio video, streaming audio video, interactive games, and text messaging. And what about the typical IP infrastructure? Does it provide us with some guarantees? No. No, it doesn't provide us with any guarantees. So the whole concept is best effort, at which internet and IP technology is based. So that's why when voice over IP service, we can compare voice over IP telephony with fixed telephony or mobile telephone, digital telephony. We can say that it is not acceptable in some cases. Why? Because the nature of the IP technology, which is best effort technology, with no guarantees. But of course, there are some protocols oriented on the establishing some parameters of the link, of the path, and even protocols which allows you to guarantee these parameters. Now let's have a look what is happening with path characteristics while transferring packets. So here you can see at the left constant bitrate transmission, for example, audio transmission or video transmission. Due to processing, packet processing in infrastructure, you can see a network delay. And what is more important, this delay is variable. And this is called delay jitter. That's why we can have here in the middle client reception, which is shifted by different delays. And finally, using buffer, we can align this delay, varying delay, towards constant bitrate play out at the client side. As you can see, client-side buffering compensate for network added delay, but client playout delay limits interaction possibility. So in the command response scenario, you cannot respond while not receiving command, and vice versa. The next command requires response from previous in many scenarios. So that's a limit. That limits interaction possibility. And real-time application, what is important is response time guarantees. For example, some infrastructure is enough when real-time response time is limited by 1 hour or 10 minutes, for example. Some, like speech, a conversation, requires, as I showed you before, half a second at most. The next problem is that playout delay should not vary too much. For example, people can adapt with even 1 second delay during speech conversation, but they cannot adapt when this delay is changing from time to time. So if you expect from the person who are you talking to, expect from this person that he would hear you in 10 seconds, it is not comfortable, but it's possible to wait these 10 seconds and then respond. But if it is 10 seconds, and after all, after sometimes it is 1 second, it is not possible to provide such service, and conversation is not possible. Another thing which you need to keep in mind that internet and telephone companies and telecommunication companies, they provide different service models. Historically, traditionally, internet is a best effort technology with some additions like DeepServe, like RSVP, to control bandwidth and some other parameters. As far as concerned telephone companies, they are from the very beginning oriented on constant bitrate because they sell services, speech, conversation, speech, telephony services. They cannot provide service with variable delay, for example. So they, from the very beginning, oriented on connection-oriented communications, and while transferring to packet technology, nevertheless, telecom still using sophisticated various means to guarantee different types of parameters for their services. In this table, you can see that they can have different type of services provided telephone company with guaranteed of loss, ordering, packet ordering, timing, and bitrate and bandwidth. Internet from the very beginning is the best effort technology, and of course there are some simplicity and if I remember correctly, yesterday Vyacheslav Tarasov with his during question session answered me about QoS that he is waiting for 5G because yes, it is very simple, best effort service. It doesn't require any additional protocols. And if you extend bandwidth 10 times, 100 times as we have it in 5G, or 1,000 times as in 6G, maybe it would be sufficient provision of bandwidth. But for most of the time, nobody would guarantee you this sufficient provision of bandwidth all the time. And what is good enough, it is also questionable. So that's why IP network use some QoS mechanics technologies, like is deep services, differentiated services, like RSVP and some others. Let me see. So to summarize, to put it easy, there are several service models, best effort, differentiated services, for example, DiffServ in IP network, covered by RFC 2475 and others, where packets are marked and in a network equipment you set up policy and scheduler using this policy, process packets in a different ways, taking into account markings. And finally, the third one service model is quality of service guaranteed. This is RSVP, for example, covered by RFC 2210, 2205, or mentioned above 3, 4, 5, 6G services of mobile network operator. They are going beyond classification, marking, policy, and scheduling towards call admission and signaling, and a reservation of resources and allocation. For example, so here is a brief topology of RSVP protocol where you can have support of this protocol on each equipment from end to end. From this topology, you can see that you cannot exclude any portion in this chain, any router in this chain. Otherwise, you cannot guarantee that it wouldn't be the bottleneck within these flows. As far as concern QoS, LTE QoS, of course, as I mentioned before, mobile network operators, they have sophisticated techniques and technologies to support this QoS. But what is the scope of this QoS? Let me see. The scope of this QoS is mobile end devices and PD and gateway. The problem is that you cannot have it globally. Each mobile network operator has its own QoS policies. And yes, inside the network, it is created so-called bearers, default and dedicated bearers. In few words, it's working like this. Some technique, even machine learning technique, is used to identify the service using some signature in IP flows and identify IP flows, and then set up policy in PDN gateway in the form of bearers, which is working across the mobile operator network. As far as concern bigger picture like this, let me see, bigger picture. you need to how it is called, harmonize QoS policy of different operators in order to support QoS for roaming mobile devices while they are in a visited mobile carrier network. So this is a subject of contracts, a subject of service level agreements, so-called service level agreement contracts between mobile operators or between service operator in the internet and mobile operators. So that's why television, for example, of some mobile operators are working quite good because it's a service by mobile operator. And it doesn't need to harmonize it within its network because it controls its own network. When we're speaking about the mobile service, not within mobile operator network, we need some agreements between service holder, internet service holder, and mobile operator in order to transfer QoS parameters of the service towards bearer, let me see, towards bearers of the mobile operator. So this cannot be done by the phone call into support. So you cannot call and say, I wrote an application, mobile application, and I want, for example, bearer type 5. The operator wouldn't speak in that way. It's not up to support. It's up to management, up to tariff plans, up to your contracts between you and the mobile operator. So you need to have a business idea. You need to talk it over with a mobile operator, and then you can harmonize your requirements, your mobile application requirements, your network, intranet or IP network policy, marking policy, QoS policy, and the policy of mobile operator, for example, and create some tariff plans, new tariff plans, which include your service, your mobile service in these tariff plans. Finally, let me show you how it works inside the infrastructure network, inside the pure IP network. And this can be done by packet tracer as well, by using diffserv, which is supported by the packet tracer. What is diffserv? In a nutshell, this is marking technology, which marks packet, and packet is marked in type of service in IP version 4, or by the corresponding field in the IP version 6. I will show you. 6 bits are used for differentiated services code point DSCP. 2 bits are unused. This protocol is defined by the RFC and mentioned here. So how it works? On each device, on the end device especially, you set up classifier which classify packets on the basis of ports, for example, numbers, and protocol numbers. Then you create a policy which mark packets according classifier. And finally, you create a policy for inbound or outbound traffic and bind it to some interface. So typically, you create marking policy on the edge routers close to the sources of packets, for example, IP phones, or video streaming server. And then on the core routing, you specify the policy, preference policy, bandwidth percentage division policies, according already marked at the edge routers packets. So as you can see in this scheme, it's very simple inside the core network, because policy doesn't um, require some sophisticated and complex procedures and more sophisticated procedures on the edge route in order to mark packets and first of all classify traffic, classify packets. Why classification problem can be not so easy, and when it is not so easy, it is not so easy when you don't have a direct connection to the source. For example, if you have a phone, IP phone connected to the port of the router, you know that this is a so-called medical fact. You know that this particular phone is connected to port number 1. It's a fact. But if you have some other intermediate equipment, and on this port of the router you have connection from different computers from different sources, then you need to have some kind of classification. In the simplest way, it is just like that: match protocol HTTP. So this is just a match of the port number. That's all. In more sophisticated cases, you need to use even machine learning algorithms in order to extract IP flow from different other flows corresponding to, for example, IP telephony or video streaming. So here is it, how it looks like in Packet Tracer. In Packet Tracer, you, of course, can specify marking policy, classification policy, and at the same time you set up some preference policy. Let me show you, or you can also look at it in the provided files. I will show you it in Packet Tracer once again. So the marking policy is set up on ISP router. You can click on the ISP router. Let me see. I will now change the simulation, change the mode of operation of Packet Tracer to simulation mode, and then you can see some kind of web traffic. Unfortunately, I cannot share this window. Don't know how it made in Zoom, but I just talk it over. I will just try to connect through web browser to web server. I click on the smartphone 1, then choose desktop. On the desktop tab, I use a web browser. If you are working with Packet Tracer, you can repeat after me. And in the URL, I just type www.vsu.ru. As you can see, in simulation mode, there is no any packet transmission until you press capture forward button. While I'm pressing capture forward, there are some animation of packet sending, and finally you can see that it's all started from DNS, of course, DNS request and response, and finally we can see HTTP traffic running, and look at it at the VSU router. You can see that letter contains some stamp on the right downside of this packet, corner of this letter, this brown mark. So this symbolizes marking. We can look at it in more detail while double clicking on the letter and incorporate it within the window of Packet Tracer, because you cannot see other windows as far as I can understand in the Zoom. So I switch now to inbound details and outbound details. Here you can see TRFC field, which is labeled by the marking policy of the ISP router. So here is it. Let's have a look how it works in IP version 4, because there are some problem with IP version 6. I will tell you just in 1 second. So I am just typing on the URL field of the browser on the smartphone one, www minus version 4.vsu.ru, and press go. Let me see. Now just click on the capture forward in order to perform packet forwarding. It's just DNS resolution, first of all. And then it goes, let me see, HTTP traffic. You can see it's again, as in version 6 marked. You can see the brown label on the right side of the letter. And clicking on this packet will give us idea of how it works. You can see that there is a special field here. Let me extend it. DSCP, which equals 18. So this is a marking which is made available now to all routers inside the infrastructure. And VSU router now is responsible for giving this packet precedence and bandwidth allocation specified in its configuration. Unfortunately, I cannot show you configuration of the router online. You can do it by yourself on the file provided from the G drive, cell PKT. And inside the configuration of the router, you can see bandwidth allocation oriented on the this packet match. Okay. I think it's enough for Packet Tracer.
Thank you. Now we
finally let me tell you about the tools you can use when you debug, when you troubleshoot questions and problems concerning bandwidth allocation, about delay and jitter. There are several tools on the market, popular tool such as Pessler network monitor, Pessler router traffic grapher, PRTG. You can see how it looks like. So let me show you in detail here. You can see RTT and jitter values. Another tool, free tool, is continuous speed test by Star Trinity. You can download it for your Android operating system or any other operating system it supports. Also, it supports you with jitter, and here you can see how it looks like on mobile operating system, the result of testing. Finally, you can use online tools from speedcloudflare.com and sponsored by Netflix Fastcom site. You can see my phone results here, which gives you some idea about what is the latency, what is a jitter, and how they are changing in time. Also, take into account that measuring more complex path characteristics behavior, for example, caused by the buffer bloat, requires some load, which you need to set by the very popular, also free tools like net performance, performance and iPerf, netperf and iPerf. Both tools can be used to generate traffic, UDP, TCP traffic, and you can see here the good behavior, which shows you that delay is changing, of course, by the TCP load, download and upload, but it is predictable, and it doesn't have very big spikes here. So that's why you can, of course, need to check your infrastructure, network infrastructure, underload various loads to check what is a problem within your mobile application. For those interested in more detailed information about how 3, 4G, 5G network deal with mobile application traffic, how quality of service are implemented in them, in these technologies, I suggest you to read Sauter and get the book from Sauter. It's the very best book about mobile network internals. Some introductory QoS application requirements and general IP version 4, version 6 information you could get from the best, to my opinion, book by Cross and Ross, Computer Network. Now it is 8th edition in 2021 released, and some particular references about policy and charging control, the main elements within mobile network, and which is under control, of course, mobile operator, and some information about LTE and 5G QoS architecture, and load test under load. So finally, please go for a quiz and the feedback. I set up here some references. Try to paste it in chat Let me see, what is it?
Dear Andrei, please clip your Google Drive links, if it's possible, to the Moodle system.
To answer some question about topics we've covered today and feedback of this presentation. Okay, I will increase volume. Sorry for setting up volume low because I have a very bad echoes, which uncomfortable while you're speaking. So I'm ready for your answers, for your questions, sorry.
Please, dear participants, do you have any questions? May I ask one question, Andrei?
Okay.
I want to ask about infrastructure, about this picture where you can show us the structure of this transfer between smartphone and server. Can you show one more time? Basic structure which you use in your presentation.
Just one moment. Так, сейчас, секундочку. Так. Can you see?
Basic structure with servers and smartphones and
Okay.
simulator.
Okay. In Packet Tracer, right?
Tracer, yes.
In Packet Tracer, right? Oh, sorry.
You have this scheme on your presentation too, not only in Packet Tracer.
Okay, understand. Just one moment. Just one moment.
Yeah. Just I saw. Yeah, this way. My question is it real and working right now? If you, it means, is it only simulation or it works like in reality?
Okay, I understand your question. Please, sorry for just maybe some delays because I can hear, personally, I can hear approximately 5-6 copies of echoes. So it's absolutely impossible for me to understand, almost impossible. So as far as I can understand your question, you're asking about the level at which Cisco Packet Tracer simulate and close to real networks.
Close to real.
Let me tell you.
How it close to real net?
Yes, I understand your question. So first of all, it works on the packet level. It means that marking, for example, fields of packets are just as they are in real network. So it is packet-based simulator, and it means it's very close to reality. As far as concerned infrastructure, topology, It is to some extent close, because you may say, converge, how it is called, it's turn, it simplifies hardware infrastructure of base stations. So you cannot see here any signals, any frequency bands, handovers, radio interface handovers, for example. There is nothing about this except maybe the physical range, physical distance between the mobile smartphone, for example, and cell base station. This can be done in physical view, physical map of the packet tracer. That's all. And as far as concerned IP, it is very close to reality. What is maybe another very rough thing here is that it cannot correctly simulate loads, delays, for example, because there are some efforts from the team of Cisco Packet Tracer developer in this direction, but they're very, you may say, very rough. For example, they can show you delays while pinging. They can show you delays corresponding to ARP protocol, for example. So the first ping may be lost. Some features of IP networks, they are very closely simulated. But you need to understand that this is not an emulator. This is not an emulator. This is not a functional model. This is a model which is trying to be close to functional, trying to be close to emulation, but it is not emulation. If you want emulation, you need to use some other tools, such as GNS, such as, for example, some Cisco also proprietary tools, but it's free GNS, because they emulate equipment. Cisco Packet Tracer doesn't emulate. It perform close to emulation, but not fully functional modeling. It is enough for basic understanding how infrastructure looks like, what you can do with packets, what you can do with characteristics of the path. It can be done very close to reality.
Thank you very much. As Olga said, Olga Vybranova said us that it may be near 85% of real equipment. It's realized near 85% of real equipment. She write it in the chat. And okay, we understand that if we want to simulate or emulate real network with a lot of features, a lot of real, a lot of emulators of real devices, we need to use something like proprietary software from Cisco or another software. But this packet tracer good tool for first good and free tool for first level development of this type of network with to show us a tracing process.
Okay.
Thank you very much, Andrei. Thank you for your good and very interesting presentation. I think everybody can ask you about your lecture in the Moodle system. And now we have a break for the dinner. And after that, we have another one lecture from Voronezh State University from Vladislav Polyansky. Vladislav, are you hear us? Okay, I think he will start in time. Thank you one more time, Andrei. We will go to the break.
Thank you, everybody. Thank you, everyone.
Уважаемые участники, сейчас у нас лекция Mobile Product Management, Владислав Полянский, Воронежский государственный университет. Dear participants, now we are waiting lecture Mobile Product Management by Владислав Полянский, Воронеж State University. Vladislav, are you hear us?
Yes, can you hear me?
Yes,
Hello.
Sound is good. Please, you can show your presentation, share your presentation.
Great, please give me 3 more minutes. I will prepare everything and we'll start
Okay.
in 5 minutes. Hello, everyone. Can you hear me?
Yes. Are you ready?
Great. I'm ready. Yep.
Okay. Please share your screen.
Just a moment. So. Can you provide me such a right to share the screen? I can do it at the moment because I have no rights.
We did it.
Just a moment. So, can you see my screen?
Yes, everything good.
Great. Let's start then. We will talk a bit about the mobile market itself. And we will talk about the development process and the cost of your ideas or hypotheses. And we will spend some time discovering the unit economy framework and how to achieve a multiple growth. So let's start. The first I'd like to talk is the mobile market itself. As you can see from this screenshot, mobile market growth multiple from 10 billions to 17 billions in 2017, and it continues growth. So the mobile market has a huge potential to drive the world economic itself, and huge possibilities for every studio or individual developer or for everyone who'd like to spend some time developing apps. So it's a forecast of the mobile market, and Sensor Tower forecast that in 2023 it will grow to $150 billion. And in this year it's on the level of $125 billion, and this is a huge amount of money. If you'd like to find some possibility, or you would like to find some idea which app to develop, or if you'd like to find some idea of the app to develop for your team, it's a good idea to start from the service called Sensor Tower, from which you can get the as you can see from this screen, you can find some estimations of downloads and revenue for any given app. So if you have an idea of, for example, some health or fitness app, or for example, some food delivery app, or for example, something else, you can just check your idea here first. And it's a good idea not to spend thousands of dollars, millions of dollars to develop in some app. Instead of this, it's a good idea to research a bit. So if you'd like to develop, for example, some kind of breathe app that you can now see a lot in App Store or in Google Play or in other stores, you can just open Sensor Tower. Just a moment. And find how much revenue drives such kind of apps. For example, you can find something like Breathe. And you can see some estimations for the apps, how much of revenue they drive and how much of installs they achieve per month. And if you find that it's a perspective niche, then you can start development process, of course. But it's a good idea to estimate such a value, how much your idea can drive as a forecast. So let's talk about the ideas. Ideas, it's holy grail of the app development, and it's a good idea if you can talk to me too, so it's not just a one-man talk here. So how valuable are your ideas, do you think? Okay, I'll talk by myself. The most frequent response is that the idea costs nothing. And it's great because a couple of years ago, the answer on this question was $1 million. I have an idea which will generate $1 million, and I will not tell you my idea, and such kind of things. Nowadays, the most frequent response on this question is nothing, which is incorrect, unfortunately. Each your idea costs hundreds of thousands of dollars. We will discuss why in this session, and to understand better why is that, let's talk about time to market. And why time to market is so long and expensive. Let's imagine that you have an idea of an app, any app actually. We will not discuss games in this session because it's another real knowledge. Let's discuss some kind of utility app. Let's discuss some kind of maybe music app or healthcare app. So you have an idea, and you would like to create an app. How will be the development process will look like? I will use Maxim Dorofeyev model here to highlight the development process. And thanks to Maxim Dorofeyev for the screenshots and the framework itself. So, as usual, in each sprint, you have some tasks in your backlog, and you have a development team, which should get the task from backlog and develop it and send it to QA. So let's assume that we have, for example, 150 tasks in backlog, and we have some deadline within 10 weeks from the beginning. It may be not the very new app. It may be the iteration of your current app. It may be a new product. But anyway, you have a deadline in 10 weeks and you have 150 tasks in backlog. And you expect that you will release a version or a product itself after 10 weeks of development. Unfortunately, the development process doesn't look like this on this screen. It might look like this, for example. Every week we have our backlog, and we have some new tasks because we can see defects, some negative scenarios, we can find some bugs. Our CEO may visit some very valuable conference somewhere in Silicon Valley, and they found some silver bullet, and he may came back and tell, guys, I have a great idea. That is thing that we can see every time. Something works not as expected. And if we just will add 5 new tasks every week, in addition to our backlog, you can see that the release date will shift a bit, just a bit, for a month, for 4 additional weeks, if we just will add 5 new tasks every week. But unfortunately, that might be not so good, as you can see even on this picture. It may look like this, for example. And if you have just 20 new tasks per week, it might be a divergent process at all, and you may never face your release. That's why we have project managers that they should rule the process. They should prioritize tasks, and but anyway, you will never release your update or product in time, unfortunately. Slight shifts always here. We can predict using math statistics and some other tools. There are many frameworks how to predict the release cycles and how to predict when the release will be. For example, if we will use the Maxim Dorofeev model, we can see then if we just will add 5 new tasks per week, the most likely we will see the release on 17 week instead of 10 week. All this sequence of screenshots are created just to highlight the idea of that the process of the development is a very, very difficult. Just a moment. And if you're developing, if you are developing some kind of software product, for example, mobile app or something else, and if you have some deadlines, highly likely you will not face the deadlines, and it will shift to the future date. Why that should affect the your ideas, and why this affects the economy? We can understand why this affects the product economy, but how that should affect the way you are thinking about the mobile product or any other product, the product at all. Let's talk about the cost of the team. On each project, you have some team. It might be a small team of startup. It may be a middle team for small companies. It may be a huge team in big companies like Google, Facebook. And let's talk about how much each developer will cost to you per month. And it's not surprising that each software developer costs a lot, and each experienced developer costs much more. And for example, if we'll take companies like Yandex or Mail or something like that, each employee will cost you up to $10,000. In the middle of $5,000. We will talk not only about the salary. We can count here the place the developer work, the price of the laptop or the price of the, I don't know, medical care. Huge companies provide a lot of interesting things because a lot of preferences which software developers like. And the salary might be $2,000 or $3,000, but you should count taxes and everything else. And at all, each software developer will cost you in the middle $5,000 per week in a big companies. Maybe a bit less in startups, to maybe $3,000. So if you are developing a mobile app, or if you developing any other software product, you have some kind of team. It's not usually one software developer. And let's imagine you have an idea. As we can see from the previous screenshot, the idea will last for 12 weeks, for example, 3 months, 2 months, 3 months, 1 month. It's very uncommon if the company can work in the Scrum methodology and they have 2-week sprints and they achieve them all the time. Most of time, the development process of each sprint took much more than 2 weeks, 4, 8, 12. So even 1 month of developing your idea costs you at least $50,000 if you have a team of 10 software developers. 2 months will cost you $100,000, and it's a huge amount of money. The worst thing here that it's not only the money you spend on the team. The idea might not work at all at the end. So you can create some hypothesis, you can create some idea of some improvement to your mobile app or some new mobile app. You may spend a lot of money, huge amount of money on development, and you may get nothing at the end, nothing at all. And that's a problem. No one wants to spend hundreds of thousands of dollars on nothing. Everyone would like to spend money to generate money. We will not talk about the software development as a service. In the software development companies, which develop software by demand. If they have some order, they develop software for some another company. We don't talk about such kinds of things. We talk about the product area of software development. A lot of teams, a lot of companies make some products. Each a separate thing. For example, in Yandex, like Yandex Music, like Kinopoisk, like I don't know, a lot of other services, Yandex After, for example. It's a different team which work with different targets, which have separate budgets, and I talk about such kind of projects. The main goal of each product, of each project, is to generate revenue. So it shouldn't just take your money. It should get your money back. And it would be great if it will get you back multiple amounts of money. If you spend 1,000, you would expect to get 2,000, 3,000, $100,000. And it seems that not a good idea to generate a lot of ideas or hypotheses. Each idea costs your company or you if you work on yourself, if you're individual software developer. Each your idea costs you money. And we can think, we should think, what can we do here? How we can improve the process, and what the idea of how to create great ideas, how to create good ideas, not to just burn out money, but to drive your revenue. So the statistics tells us that just one of two ideas will add value, will generate you money. There are some successful teams, great teams, great companies which can create such a good ideas in which flow 2 or 3 from 10 will work. But highly likely that 9 of your 10 ideas will just burn out your budgets. And it will each idea will cost you, as we can see from here, $10,000, $15,000, and $100,000. And just one of this idea will work statistically. So we need some framework maybe to create good ideas. And fortunately, it's not very difficult. It's difficult, of course, but there is a framework which will help you to generate good ideas and which will help you to avoid ideas which will not help you and which will not work for you. Just a moment. So we need ideas which will provide exponential growth. If you create an idea which will make you from $1,000, $1,020, or $1,200, it's not a good idea, because just one of your idea will work and another will not, and you spend a lot of money, and you should make your target to create very valuable ideas, the ideas which will provide you multiple growth. For example, 5 times, 10 times. If you generate $1,000, you'd like to create an idea which will help you to generate $10,000, because you will spend at least $9,000 to 9 ideas which will not work. So how the product works? Product, I will use here the naming product, which you can substitute with a lot of things. It might be a mobile app. It might be, for example, some service. It might be some physical business, maybe even some store or some such kind of things. Anyway, any product works the same. It works very simple. You have some user flow, you acquire users in some way, and you generate revenue. And you have some black box in between. This black box is what makes your business, or what makes your app, what makes your software magic. You do some magic inside this black box, and you transform users into revenue. You get some user and you generate revenue. That is how the product works. There are a lot of different naming conventions how to describe this process. I will use, for example, CPA. It's a cost per acquisition. It's the price for which we can acquire one user CPA. I will use the name MPU. It's average margin per user. That is the amount of money that generate you each user you acquire. So to understand how much profit can you get, you can use just a simple formula. You can get the amount of users you get, and you can get the CPA, and you can get MPU, and you can add them. Each user costs you money, so you should subtract this value. And each user bring you money, so you can add this value. That is the simple formula of your product. You get users, each user costs you money, and each user bring you money. And if you multiply these values, you will get the profit your product generate. Let's talk about this in a bit larger pane. You have channels to acquire users. For example, it might be some contextual ads like Yandex Direct, like Google Ads, or maybe other channels, Facebook ads, for example, Twitter ads. And that is from where you can get your cost per user, your CPA. You spend some money to drive users to your product, to your mobile app, for example. And you can count this by dividing the amount of money you spent on your users and the amount of users you acquire. That will provide you the CPA value. So you acquire some users, then you can use your sales team. You cannot, but you can. Sales or your product itself, if this is a mobile app, will convert your users into buyers. Buyers, it's a user which spends some money in your products, which buy anything in your product. And here we can see the C1 value appears. It's conversion to the first buy. It's value which we can get by dividing the amount of buyers on the amount of users we acquire. Then we can see the new value appears. It's MPPU. It's average margin per paying user. The amount of money each buyer spend in your app, for example, which provides some payments and you get some profit. So we can convert formula of the product in something a bit larger. We can add C1, conversion to the first purchase. We can get users, cost per user, and we can convert average margin per user to the conversion into the first purchase multiple on average margin per paying user. It's the same. Average margin per user differs from average margin per paying user just on the conversion to the first purchase, and you will generate some profit. There are a lot of different ways to describe how the revenue appears. You can use, for example, amount of users multiplied on the amount of money each users you bring. You can use, for example, buyers multiplied on amount of money each buyer or paying user bring. You can split average margin per paying average margin per user on the average margin per paying user multiplied on conversion. There are more complicated formulas here, and this is just the beginning, but we will not cover we will not cover them here. So let's talk here. Just a moment. Sorry. Just a moment. Just a moment. So, okay, let's discuss how to generate, how to achieve multiple growth. There is multiple growth possible at all. At the beginning of my career as a product designer, product owner, I just got $500 per month. And let's imagine that in some time my salary was increased by 20%. And I started getting $600. We can use simple maths and understand that it's just not 25, so 25, of course. It's just 20% growth. Anyway, we can see that my salary just increased by 20% here, yes? And the question here is, what is the amount of my free money I get from this increase? To understand here, we can use very simple logic here. Let's imagine that I spent $450 each month, and that I just got $50 at the end of the month. So at the end of the month, I got just $53 free money. When my salary increased on 20%, I start getting $600. And if I continue spending the same $450 at the end of the month, I will get 150 free money. $150 as free money. That's a huge increase in 300%. In other words, I will get I got just 20% growth of my salary, but my free money at the end of the month increased by 3,000%. It's more than 10 times more. 10 times. Why this happens? You can easily see that this happens because the structure of the expenses not changing here. We have the same expenses in first case and the second case. And that is the place where the multiple growth possible. That's not the only place, but it's the place that is possible at all. We can find multiple growth. In there, there is some subtraction operation. For example, if we'll take average margin per user, for example, and cost per acquisition, and the multiple amount of, for example, if we raise average margin per user and will leave the cost per acquisition on the same level, we can achieve a multiple growth in revenue and profit here. I will show a bit later how this works and some estimations you can get from here. For example, you can get them in average price and cost of goods sold. And if you, for example, increase your price in your product and will keep the cost of goods sold on the same level, here might appear the multiple growth. So let's talk about the usual mobile product here. Let's discuss some common app. And we will use this table for this. It's not very difficult. It's not difficult at all. We can use this if you know math on the level of the 6th grade and you know how to use persons. From left to right, as discussed, we have some user flow. For example, 20,000 users per week. If not discussed other than this works in a monthly time frame. So here we discuss the economy of some mobile app in the monthly time frame. So it generates 20,000 users per month in some way. I don't know how, but somehow. We can use some usual conversion level, which converts 20,000 users to 200 buyers. The usual conversion, if you don't do some magic, if you don't have a good expertise, experience in this area, will be 1%. It's a good approximation of the conversion to the first purchase. Next, we have some amount of orders or payments. It differs from the amount of buyers because each buyer can make some, not just one order. It may generate, it may do 2 orders, 3 orders, 5 orders. So next, we should skip the average revenue per paying user, and we should take a look at the average price. Average price, it's the, for example, if we discuss mobile app, it's the price of your in-app purchase. For example, if this unlocks some functionality within your app, the unlock of this functionality might cost your user, for example, $10. And as you can know, the mobile platforms like App Store and Play Market, they cut their commission, and it depends on your developer state on how much revenue you generate. It might vary from the 30 to 15% nowadays. So for each $10 user spent in your app, you just got $7. But user might spend not only $10. If you don't know how much purchases in average generate your users, the good approximation is 1.2. It's industrial standard, and if you will examine a lot of businesses, if you examine a lot of apps, if you examine a lot of products, you will see that this amount is highly likely will be near this figure, 1.2 average payment of average payment count, this value. So knowing price, commissions, and average payment count, we can get average revenue per paying user. And this is will be this. We just multiple these three amounts and these three figures, and we get some amount here. That is how much every revenue every buyer generates. Unfortunately, in nowadays in Russia, there is no some convention that different teams or different developers, different I don't know, use. You can see here average revenue per paying user, average margin per paying user. Of course, the revenue and margin, they are different. The revenue is the amount of money users brings to your product, and the margin is the amount of money you got after you subtract all the cost of goods sold. But you can see here, if you will use these frameworks, this framework called unit economy, you can see different naming. That is because of this framework is very young. It's not have some strong conventions of naming, unfortunately. Anyway, let's continue. We can get here some average revenue per paying users. If we go further, we can count the unit economy in the paying of each users. Average revenue per user, it's the amount of money each user you acquire brings to your product. And it's it calculates very easy. You just divide your revenue on your user flow, and you get this figure. And you have some CPA. It's the figure which shows you how much money each user costs you. In this case, it's 10 cents. And we can see from this case that you get just 9 cents from each accurate user. This leads us to the negative profit value, and it's it looks like it looks not like a good business. It generates revenue, but it doesn't generate profit, because you give some commission to App Store, for example, and you have some acquisition cost. Sorry. That is the very simple representation of the unit economy of the mobile app. Just the basics, and you can increase the amount of conversions here. You can split it to the different price matrices. But let's discuss just this simple case. It will provide you the idea of how to generate your ideas, how to grow your business, your mobile app, your product. And that is not very difficult. You should notice that we have some point of growth. The first point is user acquisition. We can acquire more users. Usually it's difficult. To be honest, I don't know how to acquire 20,000 users by just $2,000. 10 cents per user in mobile industry, it's not a standard. Most likely you will see the numbers here will look like something like this, or even like this, because $1 is a good estimation of how much will cost you each user in mobile industry. You can use, of course, some tactics like App Store optimization. It's not the area of this talking, but you can decrease the cost of user acquisition. But in general, the average in industry is around the $1. In some competitive markets like United States, like Great Britain, or maybe Germany, China, it may even be $3 to $5 per user, or even $10, depend on the niche. So, but let's imagine that the team which developed this mobile app have some superpower, and they can acquire users just for 10 cents. They have some organic traffic, they have some paid traffic, and in the average, their user costs them 10 cents. It looks very difficult idea to increase the amount of users on this price, on this CPA. Next, you can notice which might affect the economy of this mobile app is the conversion, and it's in 15% of in 50% of cases, it's the point you should take a look at. Because just by increasing this on half of a percent point, you will notice that you get the positive unit economy, positive product economy. You just increase your conversion by half a point of percent, and you will immediately get a positive profit from the negative. That happened because your average revenue per user becomes larger than cost per acquisition, and that is where the growth is possible. If you can somehow increase your average revenue per user by increasing conversion, by some other tactics, if you the same time can keep the structure of your expenses, so your COGS, so-called cost of goods sold, on the same level, you will get the multiple growth here. For example, it's a good strategy to make some experiments with pricing. You can just, for example, increase price by $1. It's just 10 persons here, and you will get immediately growth in profit for around 50% here. Let's compare. I will make a copy. For example, if you had $10 and $11, you will get a growth in and this will be, you will get a growth in 48% here, when here you just got difference in 10%, as you can see. So you just change 10% here and you got 50% here. There are some another points in unit economy of each product that might grow your profit by times. The next point here is average payment count. Average payment count, the easiest way to work here is to add some recurrent payments to your product, some kind of subscription. And if you do so, you can get something like this. It's huge growth of your revenue. That is why nowadays you can see that a lot of mobile products, mobile apps, even not services which should use subscription add this like Amazon, Ozon, Yandex, I don't know, a lot of services add their to their product subscription model. That is because it grows your profit by 10 times, 20 times. We just increase here in, as you can see, by 4 times, but we get growth here. Sorry. 12 times. So we have 3 main points here of how you can grow your product, your mobile app, for example. This is the growth of conversion. This is the growth of your price, or change the structure of your price, and that is the adding of the recurrent payments, for example, as a subscription. Knowing this idea, you can generate hypotheses which will work better than before, because you can point, you can concentrate on the hypothesis which will increase the economy metrics in the right places. For example, if you'd like to increase the conversion, it's a good idea to place the button buy on the visible place. You might be it might be strange, but a lot of services, a lot of products suffer because they don't have a button buy on the visible place, and if you should find this button to buy something, to spend this money in the product. It's a good idea to put a paywall, for example, if we are talking about the mobile apps, on the very beginning of your onboarding process. Because only in the first session of the using of your products, you got all your users, all your 100% of your users. On the second session, you will see the decrease of your users because of retention. You cannot retain all the users on the second session. If you know how, just tell me how. That's why it's a good idea to put the subscription screen on the very first session, on the very first place. You should, of course, for example, use some onboarding and explain your user the value of your product, the value of your mobile app. But you should suggest the user to buy your product right at the beginning of using this product. Else, you may not be able to contact to part of your users on the second, on the third, on the fourth session. So knowing by that you should increase the conversion, you can do some, you can generate some ideas here, as I just told. Knowing that you can increase your profit by in 12 times, so you can generate ideas how to convert your product or your mobile app into the subscription model. For example, if you don't use subscription, it's a good idea to change your monetization model to subscription model. And it will be a strong idea. This idea might, it might not, but it might, in theory, generate your multiple growth. And you should generate such kind of ideas. And this framework, this unit economy framework, will help you in this. You can see all the numbers here. There are not a lot of numbers, but changing there here will provide you some basic ideas of the improvement of your product. For example, if we just use some realistic increase here, let's say we can increase the conversion on 20% just. We can increase here just $3, and we can do something here. We cannot use the recurrent subscription model. We can use it if you will have a product owner which will successfully migrate model from the premium model, for example. You may see such numbers here, for example. And there is a nice book of Eliyahu Goldratt, which tells us that in every process there is just one thick place, and we can found it easily here by doing the next. Let's get the source model. We have one person here, we have $10 here, and we have 1.2 average payment count here. Let's take a look what will happen if we change each of these parameters twice, by 2 times. Let's do next. By increasing this parameter in 2 times, we got such a growth. how to do it best. Okay. Sorry, just give me a moment. We'll do it a bit faster. Pricing here twice. And we can from here we can see that changing each of these parameters in 2 times will provide us the same growth in our profit. But there are huge difference in the cost of the development of these ideas. For example, to get the growth in conversion into the first purchase in 2 times, it's a lot of work. You can you should involve designer, you should involve UI UX specialist, you should involve software developer here to create some screens, some explanations, some better UI to convert more users into your buyers. Increasing of amount of payments, it's not an easy task too. If you switch to the subscription model from freemium, you also need to make some develop and do a lot of different things. And for example, to increase or to change your price matrix, it's a very, very simple idea. To change your price, you just change your price. You just need to change it. And this is it. So in this particular case, the idea of increasing the price, once again, it's very, very simple model. Of course, you can have different pricing models, different plans, a lot of different things. But this is just to provide you some idea or vision how to cope with it. Changing the price is very easy idea to implement. You just need to change the price, and it will cost you not so much money. Case the working with the price matrix looks like the most valuable idea you can use. Hope it's clear here. Okay, I believe it's all for today. Thank you for listening. If you have any questions, I'm here ready to answer.
Is it all?
We can discuss a bit more about unit economies, but yes, it's mostly the all I would like to discuss today.
Yeah, but I want to ask our participants to give some more questions.
Yep, it will be great.
Пожалуйста, если есть вопросы, можно писать в чат или задавать напрямую. Please, dear participants, if you have any questions, you can ask in chat or directly. Okay, Vlad, do you have an account in Moodle system?
Yep.
Can you upload your presentation and this Excel file to the Moodle?
Yes, I will prepare it today and upload in a day or so.
Thank you very much.
You're welcome.
Probably you have some materials for homework of our students.
I don't know. It's a good idea to experiment with this unit economic framework. You will get a lot of insight if you don't use it or if you don't hear about it before. It's really a very, very powerful yet simple framework. You should try.
Okay. If no one has questions, I have one. If it's possible.
For sure.
Yeah. My question is: how do you think? What is the most what is the most or what is the better strategy? What is the best strategy to get money from application, from mobile application? Is the best to make an application like a small application, but everybody use it, or maybe the best strategy to use to make really good and complex application, but not for a lot of persons, or maybe something between these two strategy.
You know, it's a complicated question, and each strategy has some power, I believe. If you're a big company, you may create some huge complex products to solve some complex needs, and it will work. If you're a small individual developer, you can, unfortunately, nowadays it might be a bit difficult to be individual developer to development small applications, because most of the areas aren't free. In most of the areas, there are a lot of competitors nowadays, and you shouldn't point to create some very small, very easy, very particular applications just to solve someone their easy needs. And if you just even if you create good screenshots, good icons, good everything, good marketing, even then it's very difficult to get your share of the market nowadays with the small apps. And it's a good idea to start from developing something, some really good products. I believe nowadays the strategy make fast and release fast not work. It doesn't work nowadays.
Yeah, I mean,
you should.
In the first, in the last years, when this industry only was in progress, and the smartphone was not so powerful, it was the best strategy to make something like Agar.io, very small, with not so complex mechanics, but which can be made which made very quickly, and it works. And you think that now it isn't works, right?
It's not because of the simple apps don't work. That doesn't work. It's because of users see a lot of different apps, and it's difficult to make them purchase your product. They may download it, they may use it, but it's difficult to make them purchase. So it's the focus here is to focus on explanation of the value of your product to your users. It might be very simple, completely very absolutely simple, but you should explain to your users why it will helpful for them, which value it brings to their lives. And if you can do so,
need to work with your client closely.
Yep, you need to work. So, the key here is a great onboarding. The first session and the great onboarding will help you to achieve success in mobile business nowadays. You may create simple product, but with great onboarding, some value from your great first session, it might work.
Thank you very much for this answer. Anybody want to give more questions?
Looks like not.
Okay. Thank you one more time. We have a small break. We have a small break before 15:30, and after 15:30 we will start with the presentation from Ali Hassanov, Baku Engineering University, Data Structures, Binary Search Tree. Dear Professor Hassanov, are you hear us?
Yes, I'm here.
Thank you.
Okay.
Are you ready? Everything good?
Yes, I think yes.
Okay. We will start 15:30.
Okay.
Thank you. Now we have a small break.
Okay.
Probably coffee break.
Oh, I'm here. Okay.
Dear Professor Hasanov, you may start. You can share your screen and your presentation.
Okay, I'm here. Just I share my screen and I start it. Oh, I think there is written I cannot share my screen while others share their
Just 1
screen.
minute,
So
1 minute. Just we do it. Please try one more time.
okay. Okay, I can. I think you can see my screen. Yes.
Just 1 minute.
Because I try to share entire my screen. I think I did that.
I cannot see your screen.
Oh.
Just 1 minute. Try to do it one more time.
Okay.
Okay, good. We see the screen, document, 3 terminology.
Yeah. Okay. Well, let me introduce myself. My name is Ali. Surname is Hasanov. I'm from Azerbaijan Bakü Engineering University. As you see, our topic is data structure, binary search tree. First of all, we have to know a simple definition about trees. Then we'll start our original topic. So first, tree terminology. We can divide data structure in types or elements or data structure into main types. First of all them is linear data structure, and the next one is non-linear data structure. I hope you know linear data structure. They are array, stacks, queue, dequeue, or list, or double-ended list, or double list, and etc. These call linear data structure because all elements listed, you can go from one element or from one element to the next element, or previously you can go. This is linear data structure, but not non-linear data structure is a graphs and trees. Just we learned the special type of trees. Tree data structure is a collection of data which is organized in hierarchical structure recursively, and we'll learn what's the meaning of this recursively in the next sections. First, there is some terminology which I write here, or yes. First of all, this example for a tree is a general scheme of a tree. And here you can see the letters. All these letters we call nodes. For example, C is a node, G is a node, K is node. In this case, these are letters, but sometimes, of course, A can be represent any things, any structure. It's possible, and it's centered. Just easily we say A, B, E. These are nodes. And the first node we call root node of a tree, or root of tree. We can say that. And the links between a or any two nodes we call edge. As you see here, there is written the name of it, and there is also definition you can see here. And the node if which is predecessor of any other node is called a parent node. I mean, if a node has any child, or as you see here, A is a parent node of B and C. B and C are a parent nodes of these nodes, and descendant of any node is called as a child node. In this case, we can say B and C are a child node of A. Okay. In this case, B can be defined as a parent according to D, and it can be called as a child according to A. Okay, B as a it's also possible we can say B is a parent node according to DEF, and B is a child node according to A, because A is a parent of B and DEF is a child of B. And a leaf nodes, if a node has no any child, we call this is leaf node. In this case, I, J, F, K, H are leaf nodes, because as you see here, there haven't any child nodes. And there is another definition, internal nodes. If a node has at least one child node, we call this is internal nodes. In this case, E, G, B, C, and A, of course, we can call as internal nodes. And there is another definition, degree of tree. The total number of childs of or children of any node, the total number of children of any node we call a degree of node. In this case, degree of A, this node is 2, because A has 2 childs, B and C, and B has 3 child, D, E, F, so the degree of B is 3. And there is 3 definition, level, height, and depth. Let's look them. The first, here you can see the root node, the level of root node is 0, and then the level increased by 1. I mean, B, the level of A is 0, the level of B and C is 1, the level of D, F, G, H are or is 1. Okay, and of course 0, 1, 2, 3. I mean, the level of the last these nodes is 3. And the next definition, the total number of edge from leaf node to a particular node in the longest path is called height of node. I mean, for example, the height of A is 3, because the longest, of course, you can see here, if you try to count number of edge from this node, you can get 2, because there is a 1 and 2 edge. But if we need to find the height of this node, we have to find the longest path. I mean, we can find, as you hear, the 1, 2, 3. There are 3 edges from J or I to this node, so we call the height of this node is 3. Of course, the maximum height of the any node, or the height of tree is a height of maximum of nodes. I mean, in this case, of course, if we start, or we can see the maximum of this tree, the nodes is A. The longest path here, as you see here, 1, 2, 3 nodes are here. So we call the height of A, and the height of this tree is 3. And there is another definition, depth of tree or depth of node. The total number of edge from root node to particle node is, in this case, maybe it's a reverse or vice versa of height. In this case, the total number of edge from leaf node to this node, and here the total number of edge from root node to particular node. In this case, depth of A is 0, depth of C is 1, G is 2, K is 3. Okay, by this way you can find the depth of any nodes. This is another definition. As I said, the height of any node or height of tree is a vice versa of depth of a tree or depth of current node. And there is another definition. First, the path. I talk about path here, but the path means the between any two nodes. We can, if there is a link or a collection of nodes and edge, we call the path of between these two nodes. In this case, there is written the path from A to J. Let's look from A to J. J is here. You can see here the path from A to J is A, B, E, and J. And this is A, B, E, J. You can see here A, B, G, E, J. This is a path from A to J. And the length of this path we call total amount of nodes. There are 4 nodes from A to J. We call the length of from A to J, or the path from A to J, is 4. And another definition, subtree, as you see here, first of all, A is, or the shape of here, we can see, we call this is a tree, and it has, you can see, it has left and right subtree. This is also tree, and but this is subtree of A, or this is left subtree of A, and right subtree of A. Of course, the left subtree of A can be defined as its own subtree. For example, in this case, this is also in this case, this is not a binary search tree, so you can see there is 3 node of B, so it's not a problem. But I mean, here also you can see this is a subtree, or we can call this is middle subtree. It's possible you can define that. And in here, I is also, we can call a left subtree of E, which hasn't any subtree in it. And J is also, we can call a subtree of A. Right subtree of E is J. Okay, I mean, it has, if a node itself, we can call a subtree or tree. So next, binary search tree, which our main topic. In a binary tree, every node can have a maximum of 2 children. This is how we can say the definition of binary search tree. In a binary tree, in general, in binary tree, every node can have a maximum of 2 children, 2 child. Or you can say, as I said in previously, if not if in a binary tree, the degree of n nodes must be maximum 2. Or it means the degree can be 1, 0, or 2. Okay, and in binary search tree, this is our topic. Is a binary tree. I mean, this is a binary tree which every node contains only smaller values in its left subtree and only larger values in its right subtree. And just I'll explain this sentence here. As such definition, all elements in binary search tree are unique, but generally it's unique, but sometimes maybe you can see there is not unique elements, maybe different same elements can be set in a tree. But in our topics, I explain that a binary search tree which has all elements are unique. Okay, so let's go. And as I said, the explanation of this sentence, you can see here. I mean, this is a node with a value k. This is left subtree of this node, and this is right subtree of it. And now left subtree, I'm sorry, I make a there is a equation mark not be written here. You can eliminate, there is no equation mark. I mean, all left subtree contains smaller values than this node, and all right subtree contains the value which is greater than the value k. Okay, as you see here, these are real numbers. You can see here this is our root node. As I said, the first node in a tree or top level we call root node of the tree. As you see here, this is 25 is a root node, and this is its left subtree, and this is its right subtree. You can see here, and all left elements you can see is smaller root element, and all right elements are greater than its root element. Of course, as I said, if you see this part, this is also subtree, and here you can see the same rule. I mean, if you imagine that this is our root element, let me say that this is our left subtree of 20, and this is root element, the left subtree of 20, and you can see here all left elements of left subtree are smaller than its root element, and all right subtree elements are greater than 10. Okay, I mean this rule works whole binary search tree. And let's main operations on binary search tree. There are 4 main. This is not important, but I write here because when we deleting an element, we have to use this method. So I need to explain that. There are 4 main operations on binary search tree: finding maximum and minimum elements in a binary search tree, and searching a specific element in it, or insertion any element, deletion or deleting any element from a subtree, or sorry, from a tree. And to finding maximum of a subtree, we have to go most right element, or rightmost element of a tree is a maximum of them. I mean, if you go to right, if you can go to the right, you can go. If you can go to the right subtree, let me say, you can go. If you can go there, if there is an element, for example, if there is an element right of this 40, you can go. If there is an element the right side of this 48, you can go. If there is an element right side of this 50, you can go there. Of course, there is no element. I mean, I reach the last leaf element of right side of 25. Each times I have to start make operations from root element. This is also very important. So if there is anything on right side, go. If there is anything on the right side of it, you can go, you can go, you can go. You cannot go because you reach the leaf element. So the value of this node is a maximum of them. Okay. The same way, if I need to find the minimum element of a binary search tree, you have to go left side direction. So I mean, I have started searching from root element. If there is an element left, go to there. If there is an element left side of 20, you can go. If there is an element left side, you can go. If there is an element left side, you can go. If there is an element left, you can go. But there is no an element, so it means this is the minimum element of this binary search tree. Okay, so by this way we can say the leftmost element is a minimum, rightmost element of the tree is maximum element. So next, searching elements. There is also a definition. First of all, read the search element from user. Then I'll compare the search element with the value of root node in the tree. If it's greater, I have to go right subtree. If it's smaller, I have to go left subtree. There is a written. Let me explain on this example. I mean, for example, if we need to find, for example, 38, so I'll try to find 38 from root elements. So let's start. 38 equal 25 or not? If yes, I mean I reach the finded or needed element. Of course, 38 is not equal to 25, so I have to compare. 38 is greater or smaller? 38 is greater than 25 root element, so I have to look the left side of this 25. Again, I'll start to compare. 38 greater than 36, so I have to look to the right subtree of the 36. Again, I'll try to search 38 in this subtree. So 38 is greater, this element, no. 38 is smaller, yes. So I have to look the left side of this 40. Again, I have to compare 38 is greater than the value of this, not, no. 38 is smaller than this, no. So I catch this. It's also possible directly you can compare root element, then if equal, it means you found it. Otherwise, you will try to make searching left or right subtree. By this way, we find 38. And another things, for example, if we need to find 0 in our, not still, for example, 6, let's try. Just we need to find 6 in our subtree or in our tree. So we have to start again, root node. 6 is not equal to 25. So I'll try to make a searching. 6 is smaller. Yes, I have to look left side of this subtree. Again, 6 equal 20. No, 6 smaller. So I have to look left subtree of this 20. Again, 6 is smaller than 10. So I have to look left side of, again, my subtree of 10. 5 and 6. 5 is greater than 6. Sorry, 6 is then greater than 5. In this case, I have to try to search on the right subtree of 5. Now, 8. There is an 8. 6 is smaller than this, no, this or this element. So I'll try to find left side of this element. But of course, there is nothing. This is a leaf node, and there is no any subtree of, or there is no any left subtree of this 8. But I need to find or make searching left side because 6 is smaller. In this case, in return, the 6 is not exist in our subtree. Okay, by this way, we make a search operations. There is a algorithm written step by step. Just I explain them. And insertion operations, again, there is also written insertion operation. There's a numbers. Let me show how can we insert these elements to our tree. So let me open, I already opened this paint program, you know that. And let me copy, sorry, these numbers to our paint program, and I'll try to insert all elements to our binary search tree. So let me increase it. Let me increase. Well, just I start to insert this element. Of course, initially I haven't any tree, so the first element I'll get or use as a root element. So I have to write here 10 as a root element of my tree. Next time I'll get next element 12. So each time I start to insert an element from root 1. So 12 is greater than 10. So I have to insert this 12 to the right side of 10. So I have to write here 12. Then next element is 5. 5 is smaller than 10. So I have to insert this element to the left side of this root element. This is my next element. And now next one is 4. So I start to insert 4 from root element. 4 is smaller than 10. I have to insert left side, but there is an element, so I have to insert 4, or I have to make an insertion according to or in this left subtree. 4 is smaller than 5, so I have to insert this 4 left side of this 5. So I have to write here 4. And next time, next element is 20. So I have to start inserting from root element. 20 is greater than 10. So I have to insert right side, but there is an element, so I have to insert this 20 to to in this subtree. So 20 is greater than 12. So I have to insert right side of this 20. And let me write edge here. So let me make thinner. Okay. Well, next element is 8. 8 is smaller than 10. I have to go left side of this 10. And 8 is greater than 5. So I have to insert 8 to the right side of this 5. So I have to write here 8. Next element 7. So 7 is smaller than 10. 7 is greater than 5. 7 is smaller than 7. So 8. So I have to insert 7 here. Okay. So let me draw edge. And next element is 15. So I have to start insert 15 from root element. So 15 is greater 10 than 15 is greater than 12. 15 is smaller than 20. So I have to insert this 15 left side of this 20, this element, this node. So I have to write here 15. And next, I have to insert 13 again. I start from root element. 13 is a greater than 10. 13 is greater 12. And 13 is smaller than 20. 13 is smaller than 50. So I have to insert this 13 to the left side of my 50, this node. That's all. So this is binary binary search tree representation of these numbers. In this case, as you see, if we change the order of these numbers, we can, I hope you understand, the shape of this binary search tree will be changed. So the order is very important. First of all, as I said, all other elements except first one, I set according to root or according to first element. If I change the order of these elements, I can get a different form or different shape of binary search tree. Well, I think you understand. So let me go to work on next element. And there is deletion of operation, deleting or deletion operation in binary search tree. There is 3 cases. First one, deleting a leaf node. Of course, there is, it has several operations, choice or cases when you delete a leaf node. Not several, there is 2 different methods. I'll explain them. And deleting a node with 1 child and deleting a node with 2 children or child. So let me explain deletion operation on our previously image, which this one. Okay, just let me copy it and let me open again. Okay, program, Control V. Well, just we need to delete. For example, in this case, what we need to do, a node which hasn't any child. I mean, we need to delete a leaf node, as you see here, with no children, you know that. So let's look, and there is two situations. First one, in this case, you can see here, there's a 15 with a leaf node. Sorry, let me choose a line. So this is a 15, can be deleted because this is a leaf node, and there is 28, can be deleted. This is also leaf node of this tree, binary search tree. And there is 2 situations. What's the situation? Because this 15 is a right child of its parent, and this 28 is a left child of this parent. So first of all, if we need for example 15 which the deleted element is a left child of its parent. In this case, first of all, we have to search or we have to find these 15. How can we find? For example, if we need to find 15, I have to start from root element, 15 smaller go to the left, smaller go to the left, greater go to the right, greater go to the right, greater no, smaller no. So I mean, we find it. So by this way, we have to search, first of all, the deleted element. We find it. So what we have to do? We have to check, is it left or right element of its parent? In this case, we'll learn, for example, in this case, if we need to delete the 15, we'll find 15 is the parent of its, 15 is the left child of its parent. So in this case, I have to remove or erase this link, first of all. First, I have to delete this link, then I have to delete this element. So why I have to delete this element? Because if I need to insert a new one, for example, 14, I have to start from root element, 14 smaller, smaller, and greater, greater. But there is a link, but 14 cannot be inserted here because there is our right side of this 12 is not empty. So there's a problem occur. To prevent that, I have to delete right side of this 12. Then I can insert a new element here for next time. So I have to, first of all, I have to delete this element and I have to delete this path or this edge, then I have to delete 15. Okay, and the same way, if I need to delete 28, I have to know, is it left or right child of its parent? In this case, this is a left child, so I have to delete the left edge or of its parent. I mean, first of all, I have to delete this edge, this path or edge. Oh, sorry. And then I have to insert, delete or erase this node. First of all, I have to know, is it left or right right child of its parent? Then I have to delete it. Then I have to delete the element or the node which actually I need to delete it. This is an example for deleting a leaf node. And next time, there is an example deleting a node with one child. So let's look at the situations. In this case, if we, let me use Control Z to undo all these operations. And I mean, this case, if I need to delete 30 or 12, because these two nodes has one child, only one child. So let's look if I need to delete 12 or 30. First of all, let's try to delete 12. So again, I'll start to search in this element. Where is it? Of course, I'll try to search 12 top of root element. Each times we start searching from root element. So 12 is smaller than 25, so I have to go left side. 12 is a smaller, I have to go left side. 12 is a greater, I have to go right side, go to the right side. Now 12 is a greater, no, smaller, no. I mean, I reach the deleted element. Just I check it has left or right child. In this case, I know it has right child. So this is the first rule. I have to find that does it or it has a left or right child. I learned it has right child. Next, I have to know, is it its parents' left or right child? I have to know that. Then I have to make a link by this way. I mean, in this case, this is a its parents' right child. So what I have to do? I have to link its parent's right link to its right element. So I link its parent elements with its right element. It's also possible it has left element. In this case, I have to link its parent element with its left element. It's also possible. In this case, it has the one child which is its right child and its parent's right child. So I have to link its parent right edge to its right edge. So this link automatically deleted. So after that, I can delete this node. Okay, I mean, by this way, I delete it. So after deleting this process, the right side of 10 is 15 because I link directly these two edges. And let's look if I need to delete this one. So as I said, first of all, I have to search this element. Yes, I find the element which I need to delete. Next time, I try to find does it have left or right child? I find it has left child. Then is it its parents left or right? In this case, it's also left child of its parents. So I have to make this link. Make a link. It's from its parent left child to its left child. Okay. By this way, I delete this link. Okay. And as I said here, it's also possible, for example, in this case, the 13 has right, it's also possible right child. In this case, I have to make a link that its parent's left child to its equal or assigned to its right child. In this case, it has left child, so I have to do these operations. I'll give the value for its parent's left child to its left child. By this way, I'll delete this link. At the end of it, I can delete this node. So if you need to insert a new element, for example, if you need to insert, for example, 28, you have to start inserting 28 from root element. 28, you know, it's a greater. You have to go right side. 28 is smaller. So, yeah, of course, 28 there is exists. So I cannot insert here because actually I said I work on the kind of binary search tree which must be unique elements. So if I need to insert, for example, 29, in this case, 29 is smaller. So I have to go here because the left side of this element now is 28 because I deleted by this way. Of course, 29 is a greater, so I have to insert 28 to the right side of this 28. Well, this is deleting a node which has only one child, and this last situation, case 3, deleting a node with 2 children. So let me do it. Of course, for example, if we need to delete 20, in this case, there is 2 stations. It just I need to delete it. Of course, it's possible you can delete, but you have to move here, or you have to set this node a number or a node which we need to make a few changing the shape of tree. Okay, minimum damage it. How can I say? We need to make minimum changing on a tree when we delete 20. To get that, of course, if we deleted, some of these elements must be written here instead of 20 because we need to delete it. So there is 2 rules. If we need to delete this element, it's possible you can write instead of this element the maximum of its left subtree or the minimum of its right subtree. Okay, as I let me explain again. If I need to delete a node, I have to write instead of that the deleting one, or it's possible you can write instead of this node which you need to delete, two elements. It's possible. First one, you can write here instead of deleted one the maximum of left subtree or minimum of right subtree. So in this case, let's use when we delete here the maximum of left subtree. So as you see here, the maximum of left subtree is 15 because this left tree of this 20. So I have to find the maximum of left subtree. Of course, in the previous I said if I need to find, in this case there is a small elements, but if there is a lot of elements, of course, if you need to find the maximum of them, I have to find rightmost element here. In this case, you can see here rightmost element is 15, so I find the maximum of left subtree. So I have to write here, which I need to delete, this 15. So let's write here instead of it 15. Okay, I mean I deleted. Now in this case, as I said, my binary search tree has, or all elements must be unique. So if I insert this 15 to here, or if I copy this element or this node to here, so there are duplicate elements you can see here. So I have to make deleting operations for its left subtree. I mean, if I insert or copy past here this node, now I have to delete this value, this 15 from left subtree. Of course, the previously there is a this case one, case two. The one of them must be work here. In this case, when I do these operations, when I need to delete 15, the case one, what's it mean? Deleting a leaf node, because 15 is a leaf node. It's possible I can delete it. How, as you know, previously we talked about that. I mean, I have to try searching 15 from this root of left subtree. So I have to start searching 15 from this node, 15 greater, 15 greater. Yes, I have to delete it. Before deleting, I have to know, is it its parent left or right child? I know by this way, it's a parent of right child. So I have to delete this edge and I have to delete this value. So as you see here, when I write 15 instead of 20, the structure of this tree does not changing or changing a few. Okay, so as you see here, all the left elements of this 15 are smaller than 15, and all right elements are root element. Okay, of course, it's also possible, for example, if I need to delete, for example, 36, if I need to delete it, and it's also possible to find the minimum element of its right subtree. So what's the minimum element of its right subtree? This is 38. So if I write here instead of 36, 38, and you know, I have to delete it, link, then the element of it. And if I write instead of 36, 38, the structure of this subtree doesn't changing a lot. A few, then this a few is deleting only this element. And as you see here, instead of 38, when we write here, all lefts are smaller than 38, and all right elements or right subtree element are greater than the 38. Okay, I think I can explain for you this the last kind of deleting which has two nodes. As you see here, 20 has two nodes, 10 and 22, and 36 has two nodes, 13 and 14. And I explain, or I try to explain, how can we delete these two elements. We can insert, instead of this element, the can be written instead of this. First, the maximum of left side or the minimum of right side can be inserted instead of deleting element. Now that's all. And this is deletion of node. I explained the result elements, explained step by step. Maybe I can share with you. You can see and apply them. Then there is another main things, binary search tree traversals. There is a main, sometimes you can see three type of traversal, but I add here the last one, level order traversals. These traversals according to the levels, which I explained what the level means. So just there is an in order traversal. Just I'll explain each of them. In order traversal, the order is that left child, root, right child, and this will work recursively. And in pre-order traversal, root, left, right child, right child, and post-order traversal, left child, right child, and root. I hope you can understand that. The name of in pre-post written here according to the root. In, it means the root must be in or between left and right child. Pre-order, pre, it means the root must be written or must be first of its left and right child, and post-order root will be used or written as the end of its left and right child, as you see here. And the last one, level order traversal, if we have enough time, I'll explain how it will work. So let's start in order traversal. And to work in order traversal, I have to use this shape, which we'll use here. Well, as I said, let me write here three traversals in, let me choose black one, in order. How it works, left, root, or let me write, okay, left, root, and right. Okay, we work this order. So let's try to write it. So again, or each times, or in general, we start to work from root element. So how does it work? Left, root, right. So I've started 25. Now, if it has left subtree, I have to start or work to the left subtree. Yes, in this case, you can see here 25 has a left subtree, so I have to work on left subtree. Again, 20 has left, yes. 10 is of 20. And does it have left subtree? Yes, 5. And does it have left subtree? Yes, 1. And does it have left subtree? No, it hasn't. I mean, there is no any left element, so I have to write its root element, because you can see here left, root, right. In this case, 1 has no any left, so I have to write its root element. So I have to write here 1. Then, because left, no, right, written, I'm sorry, left, root, written, and right element, it hasn't. So I complete, when I complete this part, it means I complete the left side of this 5. I mean, I complete the left of this 5, or left subtree of this 5. So left, then I work on root. So I have to write here root element here. Root element is 5, and right element is of 8. Of course, when I here, I have to move here. Again, I have to apply this method, left, root, right. In this case, 8 has no n left, so I cannot write anything. Then root element 8 I have to write here, and 8 has no n right element. So I mean this left root right operation completed. So when I complete this part, it means I complete the right part of this 5. So if I complete the 5 operation, this subtree, it means I complete the left subtree of this 10. So what I have to do, let's look. I have to complete, or I completed the left subtree of 10. I complete left. Then I need to work on root. What's the root element? Root element is 10. Then I have to work right subtree. So again, I'll move to the right subtree. Again, I'll try to perform this operation, left, root, right. In this case, 12 has no n left, so I don't do anything. Again, root element will work. I have to write root element and right element. Right element is 15, so I have to apply this left, root, right. In this case, left has no anything. I have to write root element, and right, there is no anything. I mean, I completed. So if I complete it, it means I complete the left side of this 20 because this part completed. So what I have to do, let's look. I mean, I complete left part of this 20. Just I need to write root element. I mean, I have to write 20 here. Next time, I have to work right side. So let's go to the right side. There is an element, so I have to work its left, root, right. So there is no any left, so I have to write root element. Then there is no any right element. It means I completed, and it means I complete the right left side of 25. So if I complete left side of 25, I mean if I complete left, so I have to write root element, the value of it. I have to write 25. Now I complete left side, complete root element, just I need to work on right side of this 25. So this is also sub-3, and I have to work the same way. First, I have to work left side, then root, then right side. So left, there is a sub-3, so I have to work left side of it. There is a root element. Now I'll work it by this way, left, root, right. So 28 has no any left side, so I have to write its root element because left, root, and right, there is no element on right side. So let me enlarge it. Again, 28, it has no right, it means I complete it. So if I complete it, it means I complete the left side of 30. So left side completed, then I have to write the root element 30. Then it's right side. So there is no any element right side. So I complete this part. It means I complete left side of 36. So I complete left side. So I have to write the value of root element because left root then will work on right. Now right side is a sub-3, and I have to perform again this triple left, root, right. So for this sub-3, let's perform. It has left, yes, 38 is the left side of 40. So it has left, no. So I don't write anything. Then root element must be written here. Then it has right element, no, it doesn't. So I complete it. It means I complete the left side of 40. Okay, so just I need to perform left completed, then I have to write root element here. I have to write here 40, then I have to work on right side. So right side is also a sub-3, so I have to write left, root, right, this triple here. So, and now right side has a left, yes, so I have to move here, and 45 has a left, no, so I don't do anything. I have to write root element, then it has an right element, so I complete the left side of 48. So I complete it. So what I need to do, I have to write the root element, or not root element, or root this sub-3, maybe you can say that. So I write here 48, and now I complete left, root, and base right sub-3, which has only one element. Again, I have to do the same thing, left, root, right. Now it has an n left, so I don't do anything. I have to write its root element, and it has an n right element. So this is end of my in order traversals. And I hope you can see here during, let me move down. When we make in order traversal, you can see here all elements sorted here in increasing order. Okay, so we understand that in a tree, in a binary search tree, if we make an in order traversal, we sort these elements. Well, this is in order traversal, and the next one is the order traversal. The order means root, left, right. I mean left child and right child. So let's write here the order. And let me write the main rule. I mean root, then left and right. We work this order. So first of all, I have to start again from root element of 3. So in this case, 25 is my root element, and in pre-order, I have to write its value. So I have to write here 25. I start from root element. Then next time, I have to its left side. Now left side has a subtree, and its left subtree's root element is 20. So I have to write 20 here. Again, I have to look its left side. Left side is a subtree, and the value is 10, or root element is 10, so I have to write it again. I have to look its left side. There is an subtree here, and root element of its left subtree is 5. Again, I have to look its left subtree, the 1, I'm sorry, and now I work with operation root left right, so I have to write root element here. And next time, to its left, there is no anything. Right, there is no anything. I mean, I complete root of it. So when I complete it, it means I complete root left. Just I have to work on right one. Yes, so I have to go to the right side. Now this is a subtree which has only one node, and this is a root element, so I have to write it. Next time I have to look, it's left and right subtree. There is no left and right. I mean, I complete left side of this 10. So I work root element because I write here, I complete left side. Just I need to work on right side of this subtree. So this right side is also a subtree, and 12 is the root element of its right subtree, so I have to write it. Next time, I have to look its left side. There is no any left side, so I have to complete it. I mean, root left, just I have to write this part. This is a 15, which has no any left and right. This is on the root, so I have to write here. When I complete it, it means I complete this part, which is I work root element of 20. I work complete left side of this root element or this subtree. Just I need to work right part of this subtree. Just here you can see it has only one node. I mean, it hasn't any left and right child. So I have to write 22 here. Then I have to complete, or as you see here, it hasn't any left and right child. I mean, I have to work on root element, then I have to look its left, then right. But I work on the root element because it hasn't any left and right. Then I complete it. When I complete this part, it means I complete this topic, this part is I work on root element of 25. I complete left side of this 25. Just I need to work on right side of this element. So let's start for right subtree 25, all these operations. As the definition I say case, I have to write 36 here. And now I complete root, just I have to look to left side. Left side is also sub-tree, so I have to work root left, right. So this is a root element, so I have to write 30 here. Next time, I have to look its left subtree again. Left subtree is a 3, and it has no, I have to first write its root element, then I have to look its left. There is no any left element, right, there is no any right element. I mean, I complete third left part, and I have to work, of course, 30. Just I need to perform right side, there is no anything. So I complete it. When I complete it, it means I perform this part. I complete that, I write the root element of 36, I perform left side of 36, thus I need to perform right side of 36. In this case, this is also a 3. So I have to work the same method, root left, right. So root is 40, I have to write 40 here. Now left. Left is a subtree which has no, first of all, I have to write element, and it has no left and right. So I complete left side of 40, so I write 40, complete left side, thus I have to work right side of it. Now there is any, again, 3, or this is subtree also 3, or binary search 3, so I have to work again 48 as a root element of it, thus I have to work on left side. There is a root element 45, it has no on left and right, then I complete left side of the 48, then it means I write or work root element, then left part, then the last time I have to work on right side. Right side is a 1 element, this root, the value is 50, then it has no any left and right. This way, I complete pre-order traversal. Okay, the pre-order traversal written here, you can see. The last one is, not last one, the third one, let me say that. Post-order traversal, let me write post-order. In this case, I hope we know that we have to write the value of root as the end of 2 of them. I mean, we have to work left, then right. The last time I have to use root element. Okay, post order I have to use this rule: left, right, root. So let's start to perform that. First of all, again, as the previously, we have to start from root element. So let's look. First, I start here. First of all, I need to perform left side of it, then right side, then root element, this main 3. So let's go. Now it has left side. This also is subtree. I have to look its left side. This is left side of 20. Again, this also subtree. I have to look its left side. This also subtree. I have to work its left side. Now you can see here 5, 1, 8. These are a subtree, and it has left side. 1 is its left side. Again, I start to make operations here, and 1 has no any left and right. So left, no, I mean I cannot do anything because there is nothing. Right, there is nothing. So I complete left and right. Then I have to write root elements. So I have to write here 1. Next time, left. I need to go right side of 5. Right side, there is a 1 element, which is 8, or leaf element, we can say that, because it has no any left and right. So left completed, right complete. Just I need to write the value of its root element, 8. Just I complete left side of 5, right side of 5. I mean left completed, right complete. Just I need to write root element, because left, right, then root. Just I write 5 here. When I write 5, I mean I complete left side of 10. So left completed, just I need to work on right side. Right side is a subtree. So again, I have to look its left side, then right side. Let's look. 12 has no n left. I mean, I completed, just I need to look its right side. The right side is 15. Just I need to work on it. I mean, 15 has no any left and right. It's a leaf node, so I have to write its value. Then it means I complete 12 left and right. Just I need to write 12 value of root element. Now it means I complete left side and right side of 10. Just I need to write root element of this subtree. When I write it, it means I complete the left side 20. Then I need to work on right side of 20. So in this case, the right side of 22, there is a 20 is a 22, which has no left and right. So I have to go right side, and there is no any left and right subtree. So performed, just I need to write root element of this subtree. So when I write it or perform, it means I complete left side, right side, just I need to write its root element. Just I write 20 here. Now next time, if I complete it, it means I complete the left side of 25. What's the main things? Left, right, root. So I complete left part, just I need to complete right part. So just 36, or there is a new subtree with root element 36. Just I have to do that. It has left subtree, yes. So I have to go left subtree. It has left subtree, yes. I have to go here. It has left subtree, no. Right, no. Left completed, right completed. I have to write the value of root element 28. So when I complete it, it means I complete the left side of 30. Just I need to work on right subtree, but there is nothing. It means it also completed. So left completed, right completed. So just I have to write the root element 30. And when I complete it, it means I complete left side of 36. Just I need to work right side of it. Okay, so right side, there is a new subtree. I have to work from left, right, root. Yes, the left side is 38. So I have to look. There is no anything left and right. So I have to write here 38 here. I mean, when I write it, it means I complete left side of 38. Just I have to work right side of 48. Now right side, there is a new subtree, so I have to perform left, right, root. There is a one element left side of 48. It has no any left and right, so I have to write root element of 45. When I write it, it means I complete left part of this element. Just I need to write right part. Right part, there is only one element which has an left and right. This is a root element, so I have to write root element it. So it means when I complete it, it means complete right part of 48. So left completed, right complete. Just I need to write root element. Just I write root element it. So when I complete it, it means I work left element or left part. I complete right part. Just I need to write this root element. Again, when I work it, it means I complete left part of 36, right part of 36, just root element 36. And last one, when I perform write it, it means I complete left side of 25, right side of 25, just left performed, right performed, and at least I have to write root element. So the last element is 25, which I have to write here. Now that's all about post-ordered traversal. And the last one, as I said, this is a level order. This is written according to the levels. This is the easiest way when we explain here, but a few harder when you write the program of this code, when you need to write a level order traversal. Let me write a level order. According to the name, you can see here, first of all, I have to write 25, then 20, then 36, then 10, then 22, then 30, 40, then 5, 12. Let me enlarge it. Then 28, 38, 48, 1, 8, 15, 45, and 50. Well, this is level order traversal I write here. And during the level order, when you need to write a program, we have to use a queue data structure. So we haven't enough time, so I cannot explain it. If you need to write it, you have to use, let me write here, you have to use queue data structure. You have to use, if you need to perform level order traversal, you have to use queue data structure. How does it work? First, you have to insert the root element to the queue. Then each times you have to get the element from queue. Of course, you know, the queue works first in, first out principle. So if you insert 25, then you have to get first element of queue. Of course, the initially you insert 25, so first element is 25. So you will insert the first elements left and right right nodes. I mean, you get 25, then you will insert 20 and 36 to your queue. Then you'll write the value of root element. Then the first element is 20, so you have to insert the 20 left and right. I mean, 10 and 12 must be inserted to the queue, and you'll print the value of it. So next, first element is 36. So you have to insert get it. 36 is the first element of queue. So you have to insert its left and right subtree. I mean 30 and 40, it's left and right. You have to insert to queue and you have to print it. Next first element is 10. By this way, you can write the code. I think time is over. I need to end our lecture. Now, that's all.
1640, but if you have more information, you can get 10
possible.
minutes.
So yes,
10 minutes
let
more.
me, just I need to explain this queue. Let me give it 10 minutes. How does it work? Let me explain that. This is our queue. I hope you know how does it work. As I said, it works. This is a queue, and it works first in, first out. I hope you know that. First in, first out. First out. In this case, as I said, first time I'll insert 25 to our queue. This is our first element which I insert to my queue. Then I repeat my code while this queue is not empty. Okay, I forgot to make a close the parenthesis. Well, without any loop operation, I insert one element, root element to my queue. Then I repeat my code or my loop operations while this queue is not empty. So the first element is 25. So I have to insert 25, these elements, these nodes left and right. So I have to insert here 20, and I have to insert here, right, 36. Yes. I insert left and right node of this element, and I have to pop from my queue and write output screen or anything. Then next first element is name. So I have to write 20 these nodes. Of course, element of queue must be node because I insert 25 to my queue. This is node, so I insert it. This is a node. I have to insert its left and right. So The left one is 10, as you see here. The 20's left is 10, and right is 22. I insert left and right child of 20, so I can pop from my queue. I mean, I can print out the value of it and delete it. So next, first element is 36. So I'll take it. What's the left of 36? 30, right 40. So I have to write these two elements here, 30. Of course, you know, first I insert 30, then I'll insert 40. According to the definition of Q, I have to first write 30, then 40. Okay, you know that. That's all. Just I need to pop the element from my Q. So what's the next element is 10. So what's the left and right of 10? 5 and 12. So I have to write here 5 and 12. Then I have to pop this element from my queue. Of course, I'll print out the value of popped element. So what's the next first element is 22. So I have to write left and right child of 22. 22 has no any left and has no any right child, so I don't do anything, just I'll pop it from my next time is the first element 30. What's its left and right? It has left child 28, but it hasn't any right child, so I don't do, or I insert only one element, the left child, and just easily I'll pop from my queue. And next, first element is 40. Let me move to right. Well, next first element 40, I have to write is left and right. So left is 38, right is 48. So I insert its left, right, child's, and I pop it from my queue. And next 5 is my first element. I have to write, insert its left and right. This is 1 and 8. So I have to write 1 and 8. I insert it. So I have to pop this 5 from my queue. And next first element is 12. Sorry. Okay, 12. So I have to insert its left and right. It hasn't any left. It has only one right. This is 15. I have to write here 15. And now let me pop this 12 from my queue. And let me move all of them into the right side. Well, the next first element 28. 28 has no any left and right, so I don't insert anything. Just easily I'll pop this element from my queue. Next element 38. 38 has no any left and right. Just easily I'll pop from my queue. And next element 48. 48 has left and right. This is 45 and 50. Let me write 45 and 50. Let me do these operations. Well, I insert its left and right side, just easily I have to pop from my stack. And the next one is 1. 1 has no any left and right. Just easily, I have to pop from my queue. Let me move left side. Well, let me pop 1 from my stack, queue, sorry. Next element is 8. 8 has no any left and right. So I have to pop from my queue. And next element 15. 15 has right. And next element is 45. 45 has no left and right. So I have to move 45 here. Well, the next element 50. 50 has no any left and right. So I have to pop this 50 from my queue. And you see here, now my queue is empty. It means this is end of my loop operations. So when I ended it, you can see here a list of elements which I previously write here. Okay, these are same ordered numbers when I write according to these levels. This is level order traversals. Okay, I hope you can understand that. Well, that's all of our topics. Now, who has any question, you can ask now. Otherwise, I have to end my lesson, my sharing, and centering.
Okay, that's all.
Yes, that's all.
Thank you very much. Dear participants, do you have any questions? Please using chat or something else. Okay, I think it is very useful, like a practice instrument, like practice tool to work with the massive, to work with matrix, for example, and arrays, and anybody want to say something? Можно задать вопрос на русском, переведем. Okay, I see the comments. Thanks, a very useful and detailed the lecture. No questions. Okay, thank you, dear professor. I think need to add this presentation and probably print screen or screenshot of this paint screen to pin it or place it to the Moodle. And if you have any questions to students, you can add it to the Moodle too, Moodle platform too. Okay, thank you very much one more time. If no one wants to say something, we need to finish for today. And yeah, tomorrow we have another activities. Our first lecture for tomorrow will be challenges and opportunities in European healthcare themed startups. Mikhail Fedotov, Tallinn University, Estonia. Okay, thank you very much for all participants. This is the end for today. See you tomorrow. Thank you.
See you.